Okay, so today we want to continue from where we left off yesterday, and have a look at working with our data. So I don't know, Mike, did you have a plan to maybe go through shortly what we did yesterday, or do you want us to just jump right in to the next section?
So the next session is because we started with starting with data, but
Uh-huh,
we didn't even move a bit because of the challenges of finding the data and loading the data.
exactly.
So that module wasn't. But I think maybe some of the participants can agree with me if I say the introduction was perfectly done. It's just
Okay.
that the start of that module, maybe we can get a feel from 2, 3 participants if we need to go back with the introduction, or we can start with the module that we are planning to start today. Is that fine?
Yes, absolutely. I think that's a good idea. It would be great to hear from the participants what they think and
Yeah,
if there's anything they need clarified before we move ahead.
yeah.
So comments, please, from the participants. The floor is open. What do you think? What should we do? Because we need to move ahead as a group so that we're not leaving anyone behind. You could also post it in the chat and we can see what your thoughts are. Anyone? Oh, now I'll call
Good
names.
morning.
Hi, good morning.
I hope my voice is normal because I know I think I have a problem with my mic.
No,
Mike, is
we can
my
hear
voice
you
okay?
clearly.
You know my voice, my normal voice.
Yes.
We can hear you clearly.
Okay, I want to really thank the presenters for yesterday. The first one was perfect. The second one was really intimidating to me because I got lost, and later on I tried to catch up. But I feel that maybe the second module was not done properly, and that is why we are starting early, 8:30, to recap on that. To actually, yeah, I think recap, yeah, recap the right term. To do what we didn't do, we didn't finish yesterday in the second module. Thank you.
Thanks, Rispa. So there's also a suggestion from Kelvin. My suggestion is we carry on from where we left, having done a superb introduction.
Okay. Thank you. Thank you. Okay, so let's carry on then. So, from what we observed yesterday, I would really like, before we move on into working with the data, to ensure that we all have the data. Yes, I see that comment, Jacqueline. Thank you. Yes, and that's why I think it's very important that we all have our working directories set up correctly and that we have the data um, with us in the correct directory so that it's easy to move on. And because of that, let me share my screen. I'll share my screen too. I hope we can all see my screen. This is my R interface. I'll
Not
zoom
yet.
in. Oh, yeah, share. I forgot to. Yes. So now you should be able to see it.
Yep.
Awesome. Okay.
And
I'll
probably,
uh,
yeah, exactly.
I'll zoom in a bit so that we can see. Is that better? Should I zoom in once more?
Once more.
Once more? Okay.
Yeah.
Better, I guess.
Great. Yeah.
Awesome. I'll do that. So hopefully we are all familiar with what we did yesterday. where we were able to look at the different sections that we have in our RStudio interface. We have the console or the source where we are able to write our script, so that we're able to save it. We have the bottom where is the console where all the codes and all the functions that we call in R are run or are executed. We have the environment where we can see the values that we have within our environment. And at the bottom right, we have the pane where we can get help, look at our files, the plots, the packages that we have. Okay. So one thing I would want us to really get right is the concept of our working directories, finding the parts where we are within our computer and where we are working from, so that it's easy for us to find our data. All right. So do you all remember I remember that Jennifer mentioned this function called set working directory, correct? So I hope we all have our engines running. So we all have our RStudios open and up and running, right? So I would first of all like for us to run the command get working directory that we did yesterday, just to have a feel of where everybody is on our PCs, okay? So if you all run get working directory to see where you are, okay, identify where you are on your PC, and notice that for most users who are using Windows, myself, I'm using a Windows, the path will begin with a C and a full colon and a backward slash, okay? All right. So I hope you've all run that. And after you run that, we can run set working directory. I've done it here, but I want to show you a cool way or a simple way that you can be able to find out where you are, and tab complete to make it easier for you to find your bearing or to find the working directory you're looking for. So if you type set working directory, okay, tab completed, set working directory, full the double quotes. If you do the double quotes, R understands that this is something I should be reading into, and it's a path, or because we are calling set working directory, we are going to be putting the path inside. So you see up here, it says set working directory, and inside it expects you to give it the path to the directory that you want to be your working directory. Okay. So if you start with C, all right, if you start with C, or you start with whichever first letter you get here, for some you might be in C or in D, or whichever partition on your PC you have your working directory, press the full colon, okay, press the full colon, and then that's a, is that a backward or a forward? That's a forward slash, okay, that's a forward slash, and you tab complete it, okay. If you tab complete, so if I remove the forward slash, I can't tab complete. If I tab, it just presses the tab. But you have to tell it you're looking inside your PC by pressing the forward slash. And if you tab complete, it gives you a list of all the directories. You can see here of all the directories that you have within your C. Okay, and you can be able to find yourself or find where you want to work with or where your documents are. For me, I know this is it's a company laptop, so I need to go to users so I can find where my user is saved, be Waweru for me. And then where I store all my documents is within 1CG, so that I back up my data. So all my data is backed up to OneDrive. I know that's where I have all my data. And then the folder I'm looking for is under documents. Okay. And then under documents, I have them under my work documents, Becca Ildry. And under Becca Ildry, I have it under tutorials and pipelines. Okay. I'm just tab completing. I'm not typing anything. I'm just selecting. When I get to what I want, I tab complete it. It completes it. And after tutorials, I know I want to go into data carpentry. And into data carpentry, I only want that particular folder called data carpentry. And I don't want to go into any other directory. Okay. So once I press enter, okay, it has done data raw. So you have to check that you're in the correct one. I don't want to go into data raw. I just want to go into data carpentry. Okay. So that way I'm giving it an absolute path of my working directory and where I want to set it. All right. So that I know exactly where it is and it's not giving me problems. All right. So if you do Control Enter, it will set your working directory. Well, I'm just repeating what I already typed here, but yes, you can see that you're able to do that. Right. So before we move on to downloading the data that we want to use so that we're all using the same data, can we quickly know that we've all been able to set our working directory to the directory that we generated yesterday, that we created yesterday to work with? Yeah, show of hands would be really good, or comments so that I know where we are. Done, done. Okay, good, good. Happy to see that. I can see you raising your hands. You're done. Awesome. I need a show of more hands, please. We need more people to be able to do this. Or comments. Okay. Okay, good, good, Kevin. More people. I need at least more than half of this of all of us to be able to get to that point. Awesome. Awesome. Okay. Thank you, Ronald. All right, let's all do that. Let's all do that. I'll give everybody a few minutes to get to that point. Okay, a few more hands, please. One, two, three, 4, 5, 6, 7, 8. I only have 8 hands. I need more. George, okay, thank you. I see your hand. I see you done. Anybody who's experiencing problems, we need to be working from the same page. If you're having any problems, please just let us know so that we get this right. It will also make it easier for you later on when you want to work on your PC and finding your bearing. It's, as Jennifer said yesterday, it's usually one of the biggest headaches in working with R. Okay, thank you, Paris. Anybody experiencing problems, or are we all done? When everyone is quiet, okay, not yet. Frank, are you getting an error? Are you experiencing any problems? Cynthia, you say you want to see a screenshot of somebody doing on their screen. Are you experiencing some problems?
Yes.
Okay, what's going on? What's happening? Or where are you stuck? Can you try and explain?
I'm not sure about the directory that I'm using. I can see you started yours from users. I've lost from that part.
Okay, what did you get when you ran the get working directory? What was your
Bernice,
result? Yes?
can maybe we quickly make her share her screen, then we can use that as an example for everyone.
Absolutely. I think that's
Okay,
perfect.
Cynthia.
I'll stop sharing.
Okay, now you're able to share your screen, Cynthia, if you can do it quickly.
So Cynthia, can you share your screen so that we learn from from yours as an example. Okay, I see. All right, so once you run get working directory, you are able to see users and
Oh, yeah.
see users. That's perfect. So
Yeah.
you have to notice and be mindful that R is case sensitive. Okay, R is case sensitive. So when you are typing set working directory, when you typed C, you typed a smaller case, lowercase c.
Yeah.
Yeah. So can you yes, and then after your slash forward, you can now tab complete.
Complete.
So press tab, tab, not double dot. Just press tab on your keyboard.
So,
Okay.
Cynthia,
Yeah.
it's the button right below your escape button on your on the left top of your computer. It shows like two arrows. That is the tab button.
Or you can type capital U for users and tab complete as well. Okay, can you find the tab?
The tab is where I can't see.
It's written
Top
tab.
left.
It should be, yeah, on your
Oh,
top.
yeah. Sorry. I just saw it.
Okay. Yeah,
Awesome. There
awesome.
you go. So there is users. So just tab complete it. Okay, what's the next one? Just press tab again. You don't need to type the first letter, but it's okay if you have an idea where you're going. So tab complete again. Press tab.
I'm pressing, but it's not. The first one I first.
Okay.
Okay.
Uh-huh. Are you pressing tab or space?
Tab.
Okay, can you delete the spaces before after that? Yeah.
I'm
Okay.
pressing tab. I don't know why it's not. Okay. Yes.
There you go. So just give it some time. Okay, so scroll down to desktop where you want to go. Find your bearing. Okay. Press tab again. I guess you have to give your PC some time to load the list. Okay. And unfortunately, I mean, but if you also know where you need to go, you can just press or type the first letter. If it's a bit slow in loading the list. Remember, it's case sensitive, so it has to be a capital. Yeah. So once you do that, exactly, introduction into R, tab completed, good. And then the next one is
Initial stage.
Yep. Okay.
Okay.
Absolutely.
It's now complete.
Okay. That's where you are. All right.
Yeah.
Okay. So just to be on the safe side, you see you have, I think, a space after your last forward slash. Can you kindly just delete that? Because this is a command line tool and sometimes spaces will mean something. Yes. Awesome. So now you can control enter.
Okay, it's now fine.
Okay. So I hope this is, it has been a good demonstration for everybody else to be able to generate or to get to your working directory. All right.
Yeah,
You're welcome. So one thing I would want us to do though, well, you can very easily put all your files into one working directory. But as I said yesterday, it's important that you're able to also organize your working directory. So what we had done yesterday was to create a directory called data_raw. All right. If you look at my files section, I'll share. Oh, sorry, I'm speaking to myself. Okay. Share my screen. Okay. I hope you can see my screen. So if you look at at my files section, you see I have this folder called data_raw. So if you're all within your working directory, I hope you're all within your working directory, can you kindly create this directory, this folder called data_raw? So what you can do is press or click on this add button here. For those of you who don't have it, because I saw Cynthia, you don't have that within your working directory, and create this directory called data.raw. So if you just type data_raw and press OK, it will create for you that directory. All right. So let's do that. I'm not going to create it because I already have one. So I hope we are there. I hope we've all created that. Okay. I hope we're good. All right. So that we have somewhere to store our data and we get a little bit of bearing in terms of using relative paths. Okay. All right. So I hope we've all set that. We've all set that. We've all set that as our working directory and created the data.raw. All right. So the first thing we want to do now is download the data. Okay. So once we've set our working directory, all right, I'm going to delete that because I have it twice. I want us to download the data that we will use for this workshop. And I noticed yesterday we were having a bit of problems in downloading the data. So
Just a moment, Bernice.
yes.
Frank has deleted some content you're actually typing right now. Just undo because
Yeah.
all the code has disappeared.
Okay.
Just Control Z, Frank. I'm talking to Frank actually because
Okay.
he's actually typing.
Okay, what I'm going to do as you do that, Karega, to make your work easier, I'm going to upload this into the GitHub page so that you can have all the code. Okay.
Because he actually like everything. So just Control Z again. Again. There. So just click outside the. Yes. So please don't highlight anything in the document. Yeah. Okay. Thanks. Now we can go on.
Okay.
Sorry about
I
that.
will, no problem. I'm going to quickly upload something on the GitHub. Karega, so if you just check the GitHub page where Mike created the folder yesterday, I am going to upload quickly. Just give me one second so that it makes it easy for you to type and you don't have to type everything. Give 1 second. Starting with data. Yes. So let me first save it here. Okay, so I've uploaded the script, Karega, so you can easily just look at it and copy what you need. All right.
Thanks.
Okay. So going back to getting the data, all right, I am going to post, or I'm going to put this URL, okay? Because we want to use the inbuilt function within R called download.file. And we want to download it from a common repository so that we are all working with the same data. All right. So this download.file has 2 mandatory arguments. You remember we said functions will have different arguments so that they are able to execute your command correctly. So it has two mandatory arguments that you have to give it. Because it's a download.file, yes, because it's a download.file, you have to give it the path or the destination from where it's supposed to get the file. That's the URL. And number two, you have to give it a destination. You have to tell it, where do I store this data that I'm downloading? Okay, so you have to tell it where it is going to store. That's our data.raw, and the name of the file that it's going to put the data in. Okay, and because we want to download the data in a .csv format, we give it the name. Okay, so I'm going to do this. I'm going to copy this into the chat. All right, and all of you can put it in your code so that we all see, and I'm sure Karega will also put it in the HackMD so that we can all see. Okay, why am I not seeing the chat? Where's the chat?
Bernice, as you do that, I would suggest when they are copying at the HackMD, let us use the right panel, not the left. Yeah, so you can copy on the right so that you don't interfere with the HackMD.
I'm actually not doing anything on the HackMD. I'm going to put it on our chat.
Yeah, but Karega will also upload it
to the HackMD, so Karega can work on the HackMD. I have personally just put it on the chat so that if anyone wants to copy it from the chat, they can copy it from the chat or the HackMD document. Okay.
Okay.
Yeah, and I'm only putting this because I want us to all download the same data set so that we're all working with the same data set. Okay. So this is the only thing I'm going to be posting in the chat, nothing else. All right. Everything else you can get from the HackMD, as Pauline is putting it there. All right. So I've put this URL. Okay. I've put that URL in the chat. So if you type on your script, okay, if you just type download.file, you should be able to tab complete it. And if you say URL, again, you say it's an argument, so you can tab complete it as well. And make sure you put that URL I've given you in a double quote. Okay, so make sure it's in a double quote. All right, inside double quotes, so that R understands that it's a URL, it's a path. All right, and then you want to give it the next argument, which is your destination file. So again, you see it brings up the argument for destination file. All right, and this is where we need to be careful. Double quotes again because we're giving it a path. Okay, double quotes because we're giving it a path, and because we want to use a relative path here. Remember, we are within our working directory, and within our working directory we have several folders. For myself, I have 2 folders and other files. Okay, I hope we all have this data.raw. Okay, so if you put one dot, you're telling R, or you're telling your software, okay, that you're working, or your relative path is relative to the destination, that where you are right now. Okay, to the location within your PC where you are right now. That's one dot. And then the /forward is just to tell it, look inside here where I am working from, which is inside my working directory. So if I press tab, okay, it gives me a list of everything that I have here within my working directory. Okay, so this is a relative path relative to where I am. Okay, and that's why I said I wanted us to create this so that you can get a feeling of how to work with relative paths. So if I choose data.raw, okay, and I tab complete, it puts for me data.raw. All right, and I want to type the name, okay, of my file, that the file that will be downloaded. Where will it be placed? Okay, the name of the file where it will be placed. So I want us to name it portal data, okay, data joined .csv. We want it saved as a CSV file, okay? Comma separated file, okay? So I hope we are all there.
Bernice,
Yep.
there's a question from
Yes, please.
Jacqueline.
Yes, go
So
ahead.
she actually raised her hand. So yeah, Jacqueline, you can go ahead.
Thank you. That was from a little way back. I wanted to ask her the difference between she had a working directory, and then when we were setting the working directory, I see the path seems similar. Is it different or is it the same?
I was doing that to show you. I had already set my working directory, okay? So when I typed get working directory, you'd see the same. You'll see the same thing as the same thing is printed here as I have here in setting my work directory, because I had already initially set it, okay? So get working directory is to give you a bearing of where you are. And if you're not within your working directory, okay, then you set your working directory to where you want it to be. Okay?
Okay.
Yes. All right. All right. So have we all been able to do this? Have we all been able to download the file? Yeah. Okay. Are we all together? Have we downloaded the file? We need this file, all of us, so that we can be able to work with the data. Good, Ronald. I see Henrik. I see you've downloaded it. Okay. That's good. All right. I'll give us 1 or 2 minutes so that everybody is able to download the file. If you're having any errors, any problems, please speak up so we can assist. Okay, I need to see more hands. I need to see more people having able to do this. Yes, Kevin, okay. All right, more people. Grace,
Bernice,
good, you're done. Yes.
I don't know, but I am getting stuck somewhere. After
Oh,
test file and then data row, I don't have that portal data join
you
CSV.
don't have it. You have to type it. You have to type it yourself.
Okay.
Okay. You have to tell R where to store the data. Okay. So you have to type the name of that file. All right. So type the name of that file, portal underscore data underscore joint.csv, and make sure it's within double quotes. Thank you, Frank. I see you're done. Good. Brian, awesome. Okay, that's good. Irene, I see you're done.
Done. Thank you.
Awesome, awesome. Good, good. Okay, more people, more people. All right, if you're having any problems, please just let us know so that we can help, so that we are all at the same point. We need to have this data set to do anything else. Everything else we are doing needs this data. Okay. Cynthia, done. Good. More people, please. I need at least more than half of the people to be done with this so that we are able to proceed. I don't want to leave anyone behind. Okay, more hands, more hands. Anyone who is having a challenge, let us know so that we can assist. Janet, George, good. Harriet, good. Okay, okay. This is one point where it would be hard for me to go on if people haven't gotten the data, because then you'll be stuck going forth. Jacqueline, you're getting an error. Janet, you're done. Good. Janet, Jacqueline, what error are you getting, please? Jacqueline, can you please let us know what error you're getting so that we can assist?
It tells me that there's no such file.
No such file. Okay. Can you share your screen? I'll stop sharing. Others have been able to download it, so you shouldn't be getting an error with this. Share your screen so I can see, okay?
You're seeing the error in the destination file. Bernice,
Ah, yeah, there's a dot.
the full stop.
Yeah, there's a full stop. Good spot, Mike. So, Jacqueline, did you hear? Mike pointed
Yeah,
out your error. Not that one. Yeah, the one in the middle. Yes, that. Okay, good. So run that again. So you need to be on the line that you want to run your code.
what I did.
That's interesting. What's happening? Where are you? Have you set your working directory? Ah, that's the reason. So you see, you've already set your working directory to inside data.raw. Yeah, already set your working directory to inside. So yes, so can you delete that data.raw and set your working directory again? Good. So set it again. All right. And then now download. Awesome. You're done. You have your data. Hi, Mama.
Okay.
Good. All right. Awesome. So if anyone else is having an error, anyone else having an error? No? Sylvia, you got lost. Where did you get lost? Internet issues. Okay. So where are you? So we can pick you up. Where are you?
Okay, so I'm downloading the file.
Okay, it's downloading, right?
So I'm at download.file, but it's not autofilling. So I'm wondering if I've done the right thing.
What's not autofilling?
The tab complete thing. So I don't know if that was it, and then it's showing as though that it has issues like correct.
Okay.
Let me just share my screen and then
do that.
yeah.
Can I continue now?
So that's where I'm at. So I'm wondering, it's showing over here, this section at the URL here. I must have done something off.
You need to put your path within double quotes. So can you put a double quote before the HTTP? Yes, a double quote. Yes, and then at the end of it also put a double quote.
There.
You already have it there. Okay.
Okay.
You can put the path to the destination file.
All right.
Comma, dest file. Just tab complete that.
All right. Then
Double quotes.
Then that.
Yes. Dot. No, you need to put a dot first. Forward slash. Forward slash. And then tab complete.
Oh, sorry.
Yes, to data.raw. Yes.
Mm,
And type the name of the file. Portal.
sorry.
You need to type the name. Type the name of the destination file. So portal.
Okay.
Yes.
Portal.
Yes. Joined. And it's always good practice, guys. I've seen most of you have started draw. You're typing most things with capital names. It's
Okay.
usually easier. Personally, I find it easier to just use things in small
Lowercase.
lowercase. Yes. So for me,
Oh,
you'll notice most of my names are in lowercase. So I mean, it's up to you, but it always makes it just easier unless you really have to put it in caps. So it's no problem.
will it be an issue the fact that I called the file combined CSV? Or this is a whole
That's-
different thing?
That's from yesterday, right?
Oh, yeah. Yeah. Oh,
Yeah,
this is a new one. Okay.
It's not a new one. It's the same file, but I want us to be working from the same thing. Okay.
All right. I
Yes.
hear you.
So just type portal underscore joined. Is that the name? Guys, remind me. No, it's portal
Data.
underscore data underscore joined. Yes. Okay. Data underscore joined dot CSV.
All right. CSV.
Yes,
Dot.
dot
All
CSV.
right. Okay.
And then after the, yes, put up closing bracket. Close the bracket.
And then I run that.
Yes. So now you can run that. It should work now.
There's an error. Oh, okay.
It's not an error. Don't be afraid. It's fine. it's telling you, it's giving you information of what it's doing. So it's trying that URL you've given it and it has downloaded your file.
Oh,
It's
okay.
perfect.
So,
You're good.
all right.
Okay.
All right. Thank you.
Usiogope hizi vitu kawaida. You're
Okay.
fine. Okay, good.
All right. Thank you.
Sure. Aha. Who else? Who else? Who else? Who else? After we have this, I think the rest will go quite smoothly, because if you don't have the data, that will be your biggest issue. If you have the data, everything else should go fine. Anyone else? We don't want to leave anyone behind. This will make it easy for you to even work with Jennifer when you have the data. So who does not have the data yet? Let's just solve that now. Who doesn't have their data? I'm not seeing any hands. I'm not seeing any responses. Do we all have our data? If you're all quiet, I will assume we have data and I will move forward. Yeah? Okay. There are no hands, so I'm guessing everybody has their data, right? Okay. All right, so now let me share my screen again. Glad that everybody has their data, so we can move forward. So you can all see my R screen? Yes? Mike, can you see my screen?
Yes.
Okay, good. Awesome. All right, so now we have our data. Okay, I'm going to myself, I will delete that line because I already have it. Okay, and we have the data now. So you had already downloaded some packages, and for us to be able to load that data or bring that data into the R environment so that we are able to move forward, we need to call that data or load that data into R. So Mike, can you confirm which package did you download?
Tidyverse
So you downloaded the
and
whole of
ggplot.
tidyverse
Yeah.
and ggplot. Good. So can you all type this? So if you type library, it will autocomplete. You should be able to autocomplete library. And then if you type tidyverse and tab complete, you will be able to see it. I have several. So for you, you should be able to see tidyverse. Okay. So if you type that, you should be able to see tidyverse. Okay, tab complete, and you're able to see tidyverse. Make sure you have a closing bracket. I had deleted mine. And control enter, you should see library tidyverse. It should load properly. Okay, within your console down here. It doesn't give you any information, but it loads it and there's no error. So you should be good. Okay. So I hope you're all done there. So next thing, after we now download the data, we have loaded the library we need to use to call the data into R. So now we want to read the data into R. Okay, we want to call the data into R. Jennifer explained extensively yesterday about read.csv and read_.csv. Okay, so read_.csv will read our data as a table, as she said, which is a more versatile way of storing our data so that it makes it more versatile in terms of rerunning the code and making it more reproducible with different packages and libraries. The initial one was just read.csv that we used with previous versions of R and of tidyverse. But for now, because we all downloaded the current version of tidyverse, let's use read. So if you type read_.csv, you should be able to see it. Read_.csv, you'll see it because you've loaded the package tidyverse. It is within the tidyverse package. Okay. So what we are also doing here, all right, with this operator or this syntax is we are, first of all, reading the data into R and saving that data into an object called surveys. Okay. So what you want to do first is type surveys, which is your object, and then do the operator for assignment. Okay. So that we store our data within surveys. Okay. And then type the name of the function, read_csv. You can tab complete it, and then make sure you give it the correct path to your data. All right. So if you want, up here when you are doing the destination file, you can copy this path. Okay, you can directly copy that path because it is, and so that you also get the name right, because if you even spell one letter correctly or wrongly, it will give you an error. So if you can copy this, okay, you can copy this that we put here and put it here inside the read_.csv, okay, and paste it there. All right. So if you do that, you should be able to load your data and you should see something like this. Okay. So are we all there? Are we all there? Are we all good? Do we have the data? Yes, 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 yes. Awesome. Good. All right. Happy that we have the data. I hope no one is having errors. I can see lots of yeses. Good. That's awesome. All right. Okay. Now that we have loaded our data. So remember what we've done? We've loaded our data into an object called surveys. Okay. So it's no longer portal_data join.csv. It is surveys. So within R, in your environment, don't mind mine, I have a lot of things. You have surveys. You should have that data set called surveys, and it tells you, just briefly tells you this kind of numbers, okay? This is the number of observations, and that's the number of variables that you have. All right. So good. So now we want to have a look at the data, all right, and see what is within our data. Okay, we want to see what we have within our data. So now that we've read the data, okay, you see the result is that it tells you the column specifications of your data here, column specifications of your data. And then what it does, it gives you each column name and its data type. You remember we talked about data types yesterday. It gives you each column name and its data type. So when you execute read_.csv on a data file, it looks through the first 1,000 rows of each column and it will guess its data type, okay, depending on what is there. So for example, in this data set, it reads weight, okay, it reads weight here as a column double or an integer. So a column double is a numeric type of data. All right.
Bernice,
Yes.
sorry, I have a conflict somewhere. Tidyverse conflict.
Yes, it's okay. It's expected. Sometimes if you have loaded something else before and you load a package that has the same function, okay, so it tells you a few of the calls will be masked, right?
Yeah.
Yeah, so it's fine. It's not an error. It's just a warning.
Mm-hmm.
It's just a warning, and it tells you some functions will be masked because maybe another library already has a function called that way, and you can't call the same function or unless you specify from two libraries at the same time. So it's okay. It has loaded. It just gives you a warning of which ones are masked or where there's a conflict. Okay.
Okay. But
Yeah.
now
So,
I don't see what you are seeing, like the record ID. I don't see that.
have you loaded the data? Have you run this? Have you run
Yeah,
this line
I've done
29?
that. Yeah.
So in your environment, do you have something called surveys like this?
Mm,
Okay, on your right,
yeah, I have it.
you have it.
Mm-hmm.
Okay, so did you do read_csv or read.csv?
Read.csv.
Yes, you did read.csv and not read underscore. So this is an underscore,
Okay.
not a dot. Okay, so I was saying read.csv. It works, yes, but that's for a previous version and it's still okay. It's still okay.
Yeah.
It still reads the data into R, but for this particular tutorial or what we are learning today, let's use this so that we are following the same thing. So you can rerun it. Okay, there's no problem. You can just replace the dot with an underscore.
Yeah, I found it.
And
It's
it
okay
worked?
now. Yeah.
Okay, good,
Thank you.
good, good, good. All right. All right, so as I was saying, R will try and guess the type of data that you have depending on what it sees within your data set. Okay, so for example, I was saying that weight is read as a column double or as a numeric. Jacqueline, yours does not find read.csv. Have you loaded tidyverse? Have you called tidyverse into the environment? Have you run this line 23?
Yes, I did.
Okay. And if you do read_csv, you're not seeing it?
No, the error that it's giving me is this one here. It does not find that function.
Which means it has not loaded the library tidyverse into your environment.
This one
Okay.
here?
Okay, I can't see your screen. So let me stop
Oh.
sharing. Okay. Share your screen.
Mhm. So I have this.
Okay. Library
And
error package on namespace fail for tidyverse. Yikes. Okay. This is a package installation issue.
Yeah, and Jacqueline, we actually exchanged email to confirm that you already have tidyverse. I think we had an email and you confirmed that you had.
yes, it's there on the packages.
No, because now it's evident that you didn't install it.
There's no package called room. So we might try to install. So what you could do is, first of all, install this package called Broom that it's telling you is not there. But the problem with this is usually you might just find that it needs so many other dependencies on the background
Yeah.
that we might end up just installing this for the whole session. So I suggest, I don't know, if we,
Yeah, if
I
we,
wonder,
because
okay.
one thing again,
Mm-hmm.
the R that it's a bit low, the version.
Oh yeah, that's
Yeah,
right.
because she has maybe three lower than 3.5.
Because most
Yeah,
of us, I think, if you did a fresh install, you have
it's
version 4.
4
Yeah.
exactly. So we made sure most of the participants have 4. Yeah.
Mm-hmm.
So that would mean maybe reinstalling R base R.
Okay. What you can
Yeah.
quickly do, if you did tidyverse, can you do the library dplyr? Okay. So instead of tidyverse, can you call dplyr? Okay. Library. Tab complete it. Dplyr, dp, there's no I. Yes, that. Tab complete to that. Can you call that? Can you run that? Yeah. No, we can't do this now. If we end up doing this now, we are going to end up doing what we did yesterday. We'll spend the whole session installing.
Yeah. I think
Okay, I think
Jacqueline, so you can just
yeah.
follow the scripts, then we can
Yeah.
do this later on. Yeah.
Okay.
Yes.
Okay, thanks.
Kindly. Yes.
No problem.
Because
No
if we do
problem.
start to do this, you see, this is usually the problem. You will end up having to install one package after the other until they're all complete. So I would suggest that once we are done with the session, maybe during the break in a breakout room, you can install the latest version of R, number 1. Okay. And then you'll be
Okay,
able
okay.
to, they will also be, once you're also downloading, you won't have any conflicts, because now usually when they update R, then the developers will also update their packages to fit within the new version of R. Okay. So yeah, let's do that after in a breakout room.
Okay, thanks.
Apologies for that, but just follow with us, follow along, and you will have access to all the scripts and the codes, so you can always run this later on during
No
the day
problem.
by
Thanks.
yourself. Okay, sure. Okay, where were we? Loading the data. All right, so we've loaded the data. We've seen that R will try and guess the type of data that it's there, the type of data within each column or each variable. Okay, so one of the things that we'd like to do after you load your data is you want to look at the content of the data that you the content of the data that you have uploaded or called into your R. So one very nice function is called head. It's called head. Okay. So as the name suggests, okay, head will give you the first few lines, like head, literally the head. It will just give you the first few lines at the top of your data set. Okay. So if you call head, so if you just type head and then inside surveys, I'll type it just so you see how it's head. And then your data is now called surveys within R. And you can see I can tab complete it to surveys. So if you just call that, that's what you see. Okay, that's what you see in your console. You see head surveys, it types the first 6. So it's done the first 6 rows. Okay, 1, 2, 3, 4, 5, 6 rows. And it gives you the headers, a few of them. Okay, so you can see it tells you it's a table 6 by 13, 6 rows by 13 columns. Okay, and then it tells you with 5 more variables. So the variables are the columns that it was not able to display here. Okay, and what you can also do is specify the number of rows you want to see, okay, by adding this argument called n. All right. So if I do head surveys, and then remember to separate arguments using a comma, n, okay, I tab complete and I see it gives me n as an argument. It's there, yes, n. I want to see 50 lines, okay? So you can say you want to see 50, 100, 1,000, whichever one you want, okay? And I tab complete that. You see, it will give me a table 50 times 13. So it gives me the first 10 rows and tells me with 40 more rows and 5 more variables that it hasn't displayed here, all right? Okay, so the other function, okay, so I'm going to go a bit quickly, all right? But if you have any error somewhere, please raise up your hand or type it in the chat, and one of the helpers will let me know, okay? So that we make a move on. So the other cool function or feature that you can use is called print, okay? It's called print. So if you type print, if you say print, print, as the name suggests, just tells it to print, okay? It just tells it to print whatever it is you're telling it, you know, like the way you'd tell your printer to print something, okay? So I want it to print surveys, okay? But surveys, I know, is a big data set. I don't want to see the whole thing, okay? So maybe I just want to see the first 50 rows, okay? So n is equals to 50. I want to see 50 rows, all right? So you see the difference between head and print. So print will actually print for you exactly as it is, all right? So it prints for you 50 rows like you've asked, okay? Head, because of of its nature of it being just head, it's just a summary, it will only give you the first few rows. But print, because you've told it to print 50 rows, it will print for you 50 rows, okay? So it has printed for us 50 rows here. And it tells you how many more rows you have in the data set. It has with 34,736 more rows and 5 more variables, okay? Yeah, so that's what print does. And that's what it's done down there, okay? So the other thing you could do, all right, and this is something that is handy and you might want to learn, is you might want to just reassign a few rows of data, because for example, you see we have 34,786 observations in this data set. Those are a lot of rows, okay? Those are a lot of rows. So what we could do is, for the purposes of computation, because you don't want to be running a very big computation on a whole 34 rows of data, is you could subset it to a few rows that you can be able to test an algorithm on, because you see, the larger the data set that you have, the larger the amount of time and the larger the memory and CPU power that your PC will need to run this, okay? So a cool thing you can do is to subset your data, all right? So we can subset using head, okay? So I'll tell it to give me, okay, the first thing it's doing here is to give me head, okay, of surveys, and I want it to subset it to the first 100 lines, okay? So if I run this, okay, you don't get any result here, but it has run without an error, okay? And in your environment, in your global environment, you see you have samples, survey underscore sample, okay, because we've stored it under an object called survey underscore sample, okay, surveys underscore sample, and we've stored the subsetted data here inside that object. So if you look at your global environment, you'll see you have surveys underscore sample, and it has 100 observations, okay, like we've told it to subset. It has 100 observations, all right? So that's just something you can do if you have a very big complex algorithms you want to run and you want to test them out before doing it on the whole data set, okay? So that's something you can do, all right? So we've been looking at our data set, and one thing we need to now understand is that a lot of times when you have data, it's a combination of 1,000 or 100,000 of rows of data with information about maybe that data in various columns or in various vectors. In R, they're called vectors, okay? And you see R has also called them variables, all right? So data structures in R are mostly stored in data frames, okay? So R will refer to it as a data frame, okay? When we called our data today, it was stored as an object of class table, all right? It's a special kind of data frame. It's not very different from the data frame that we are talking about here, but as Jennifer was explaining very explicitly yesterday, it's more versatile, okay? So data frames are the de facto data structure for most of tabular data. And because most of the data that we have from observations, from experiments, we store it in Excel or in a tabular format, okay? And that's what we use for most statistics and plotting. Data frames can be created by hand, okay? We can create it by hand within R or by functions like read.csv, like we've called it into our R. And because we also, most of the time, will be uploading data from sheets, like spreadsheets from Excel and other, okay, and other tools, okay? So a data frame is a representation of data in the format of a table where the columns are vectors and the columns all have the same length, okay? They all have the same length. You might have data that are missing, that are not recorded, but all the columns will have the same length and they will have the same type of data. Okay, that's how R is able to guess which kind of data you have. So if a column is made up of dates, it's just dates. If a column is made up of ages, it's just ages in numerical numbers. Okay, if it's all characters, it's all characters. So all columns or vectors have to have data of a single data type. Okay, so we want to now inspect the data that we've uploaded. Okay, we want to inspect the data that we have uploaded now into R. And we'll do that with a few functions. The first most common function is called str, all right? Str. Str we did yesterday briefly, and it stands for structure, if you remember. So if you type str, okay, and then you fill in your data inside that we've called, is called surveys, okay, surveys, and you run that, okay, you run that, this is what you'll see, the first few lines of str, okay. It tells you it's a table, okay. It gives you a structure of your data. It tells you it's a table of 34,786 rows by 13 columns, okay. So the first argument is within R is usually stored as rows, okay. So the first argument will usually be rows and the second part is columns or variables, okay. So this many number of rows with this many number of columns, okay. And it gives you information about the different columns that you have, okay. So you have this number of columns, you have record ID, month, day, year, plot, species, and after the full column, you see it tries to tell you which kind of data type is within that column, okay, and how many rows, all right. So I told you all columns have the same length. You can see here, this is all the same, 1 to 34,000, okay. All of them have the same length. And for each column, it tries to tell you what is stored. It's stored in numbers. Month is also stored as a number. Day here is also stored as a number. And you can see for a few of them, like species ID is stored as a character. Sex is stored as a character. And then genus, species, taxa, and plot type are all stored as characters. And the others are stored as numbers, okay? And of course, again, it repeats because we have our data as a table. It repeats what we saw when we are reading the data into memory, okay, as the columns and what are specified within the columns, okay. So let's further inspect our data. All right, we want to know the size of our data. Okay, we want to know the size of our data. how big is our data? One of the things we can do is look at a function called dim. Okay, so dim, I want to see that again. Okay, I want to see this. It's retrieve or set the dimension of an object. Okay, so for us, what we want to do is retrieve. We want to retrieve, okay, the information about how big our data set is. All right, so dim surveys. So if you just type dim and then you type surveys inside, dim and type surveys inside, okay, and run that, you should have something like this as a result on your console. Okay, as a result on your console, this is what you should have. So as I said, the first object is always the number of rows, and the second one is stored as columns. Okay, so we have 34,786 rows with 13 columns. Okay, with 13 columns. All right. Okay. All right. So the next thing we want to do now is look at the number of rows we have. We can specifically just ask for the number of rows within surveys. Okay. So if you type n row, all right, if you type n row, and again, it's not n rows. I always make the mistake myself of writing an S after W. So it's just n row. Okay, you can tab complete it. N row surveys, okay, and run that. It gives you the number of rows. As we said, rows is always stored as the first object within dim. We saw we had 34,786 rows. Okay, and then we can also look at the number of columns specifically. Okay, the number of columns specifically with n col. Okay, with n col. All right, so n col, number of columns, and surveys. Okay, if you run that, 13 columns. Okay, so specifically we have 34,786 rows and 13 columns. Right? Okay, good. So I hope you're all good up to there. Okay, we've seen the number of columns we have and the number of rows we have in our data set. So the other thing we can do is have a look at the summary. Okay, have a look at the summary of what we have in our data. All right, have a look at the summary of what we have our data. We've already run structure. We know what structure gives us. So let's try out summary. Okay, so let's try running summary. Okay, so we want to run summary, this one that's under base R. Okay, and summary is a generic function used to produce summaries of results of various things. And for us, we want to just get a summary of our data. Okay, so if we get the summary of surveys, okay, and run that, this is what you get. Okay, so summary is really cool because it gives you summarized information of the different types of values that you have. So if you call summary on surveys, for those data sets that are stored as numbers, it calculates the minimum value, which is mean, okay, the first quantile, okay, the median number, the mean, okay, the third quantile, and the maximum value. Okay, this is given for all the columns that have numerical data within them. Okay, so record, month, day, year, these are all stored as numerical data. That's why it's able to actually do this kind of calculations, your mean, your median, and the max and minimum values. So you'll notice that for the other columns where the data is a character, okay, it tells you the length, which is the number of rows, the class, which is a character. This is why it's not able to do the basic statistics within that column, okay, and it tells it's of mode character. Okay, so because it's a character, it can't be able to do any statistics on it. So, and it does this for all your 13 columns. So if you count all of this, you'll see that there are 13 columns. Okay, good. So I hope we are all there. All right. So we can do a challenge for like 2 minutes. 2 minutes. As I also get to hear from Mike if we have any challenges, if I need to answer any questions. So for those for whom we are following along, can you try and do this challenge? Okay, can you try and do this challenge here? Yes, Mike?
So far, so good. There's no question in the chat.
Uh-huh.
Yeah. So I think maybe we can go ahead and do the challenge.
Okay,
I don't
so
know, what's your plan for a break?
what's my plan for a break? To be honest, I think I'm going to break at 10:20 when I'm leaving.
Okay.
Yes, so that I am able to attend the other one. But can we take 2 minutes to do two? Okay, let's say 5 minutes. So if you need to get a nature call within the 5 minutes, you can do it, right? And also try out the challenge. So it's now 9:49, 9:50. Let's say 9:50. Let's resume at 9:55, okay? Yes, so can we
Your
all,
time?
my time, okay, what's your time? Mine is different.
9:53.
Yangu iko nyuma sawa. Okay, so 5 minutes. So 9:53 plus 5, that's 9:58. Okay, let's say 10 o'clock. Wow, this time is moving very fast.
Okay.
Yeah, 2 seconds as I also answer my daughter's question here as well. Okay, 5 minutes.
Everyone can try the challenge and post it in the chats or in the HackMD, whichever one you find easier. Just write down your answers. Show us that you're actually doing the challenge. Awesome. Also, if you have a problem, kindly reach out right now so that we deal with it before 10.
I can see answers coming through in the chat. That's good. Good job, people. Good. That's good. I'm happy you're able to do that. That's good progress. I hope no one is having a challenge that we need to look into. The next 20 minutes will go a bit faster so that we are able to complete this module. Good. 34,786 rows and 13 columns. That's very good. Awesome. Okay, we are coming up on 5 minutes now. We're coming up on 5 minutes, so we'll shortly proceed. We'll shortly proceed. Good. Okay, awesome. I'm happy that we are able to do the challenge and we've been able to run those commands within our data and see the kind of dimensions and the structure we have within our data. So the class of our object surveys is being it gives us a special table. Okay, it gives us a special table, right? All right, special table DF. All right, it's a table and a DF. DF is simply for data frame, table, and at last it says data frame. Okay, so it's a table because we called read_.csv. Okay, and it's at the same time it's a data frame. Okay, it's a special type of data frame that's also stored as a table, but at the basics or at the core of it, it's a data frame with 34,786 rows and 13 columns. Okay, so that's what we have. All right. Okay, so let's move on and look at indexing and subsetting our data. Yesterday, we briefly looked at subsetting vectors. Okay, we looked briefly at subsetting vectors. So today we want to look at subsetting data frames, right? So the first thing we need to do or remember what I said yesterday is inherently R will store our data sets, our vectors as indices, okay? So it's going to store it as an object and a value is stored within the data set as an index, okay? So it is on this column and this row, okay? And we've said and we've seen that it will always give you rows first and columns again, okay? So if you can tell it you want to see a particular observation or a particular value by giving it the coordinates or the index for that value, okay? Because our data sets are stored as 2 dimensions, columns and rows, okay? So if you give it an index of a particular row and a particular column, it's able to give us that, okay? So for example, yesterday we used these box braces, okay, or box brackets to subset a vector by just giving it one single value because it was linear. Our vectors we were working with yesterday were very linear, okay? It was just a column, one column with several values inside. But today we actually have a data frame, okay? So it has several rows and several columns. So what you have to keep in mind is that you want to subset a data frame, okay? You give it, this is the first method that we're looking at by giving it the indexes or the coordinate of the value you want to see. So always remember the first value is the row, the second value is the column, okay? And it's separated by a comma, separating arguments in R, you separate them by columns. So let's say you want to see the first element in the first column of the data frame, okay? First element in the first column of the data frame. We say surveys. I can type this again so that we're typing with you. Surveys, okay? Box braces. I want to see it in row 1 and I want to see column 1. So if I run that, okay, that's the value, okay? The value is 1, okay? The value is 1. All right, let's try something different. So let's say I want to see in surveys, I want to see what's in row 1, column 6. What's the value there? NL, okay? NL, okay? So this character or this value, this column is a species ID, so it's a character, okay? And so the value there is NL, okay? This was a double. A double is a character, is a numerical value, okay? It tells you it was a numerical value and it was 1, all right? So this one was NL, okay? You can try it. You don't have to do the ones that I have here. You can try different things. Let's say we want to see surveys, okay? Let's say we want to see row 100 and what is in column 11, okay? So you can try anything, all right? Okay, so column 100 is species, and at that row, this is the value, whichever that is, albigula, okay? So you can play with this, play around with this with any value that comes within. But you remember, you have 34,000 rows and 13 columns. So you can't go outside your dimensions, okay? So you can't go higher than 34,786 row number here, and you can't go higher than 13 here because those are the dimensions of your data set. So you have to keep that in mind, okay? So that's the first way. And then the second thing you can do is also, you can look and ask for like all the rows, but just column 1. So like this, you see, I haven't put anything here in rows. This is to tell R, I want everything within the rows, but I only want to see column 1. So I want to see all the rows in column 1, okay? So this is also an easy way of subsetting your data. So if I run that, you see it gives me the value in column 1, which is the record ID, and all the values, but it only prints, because this is a table will only print for you the first 10. And it tells you with 34,736 more rows. Okay, so if you wanted to subset this, okay, if you wanted to just subset the first column, that's all you'd had to do. You'd only have to give it a variable, okay, and maybe say first underscore column, okay, give it the operator for reassignment. And if you run that, I'm not going to run it, but if you run that, you can have the first column of the data frame saved into this object if you wanted to. Okay, so that's the other way of subsetting your data, so that maybe you can just work with this data if you wanted to do something. All right, I hope you're together up to now. Okay, all right, so the other thing you can do, okay, is you can specify a range. Okay, you see what this does? The comma, the full colon here, okay, the full colon specifies a range of values, okay, a range of values. So for example, remember the first coordinate is rows, so I want to see row 1 to 3 in column 6. Okay, in surveys I want to see row 1 to 3 column 6. So if I run this, what do I get? Column 3 is species underscore ID, and I see 3 rows. Okay, NL, 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 they're all scored as NLs. Okay, you can do something different. Let's say you want to see more rows. Box braces, say I want to see 1 to 10 rows in column 7. Okay, you can play around with this. You can put any numbers. Okay, so this is interesting. Okay, we see that this is column 7 is sex. It's stored as a character. Okay, the first 10, the first 10 that we've specified, the first one is M, second one is M, and then you have NAs within your data. Okay, you have NAs, and they are red because R reads them or is able to understand what NAs are. They're missing values, so they are red. Okay, and then 9 is M and 10 is NA as well. Okay, all right, so this is the equivalent of saying, okay, the next one is the equivalent of saying as well that, okay, you can, is the equivalent of saying I want to see surveys rows 1 to 6, okay, but all the columns, I have not specified a column, So because you remember here above here, we had specified we don't want to see any, we want to see all the rows. So here we want to see all the columns, okay? And you can subset it as well to head surveys, okay? Just the top, the first 6 rows, but all the columns, okay? So because I don't want to save that, I'm just going to run this, okay? So remember, you can select a command and run it, okay? So if you select a command like that or select a function and you run it, it will run just that. So I didn't reassign it because I didn't run the whole line. I just ran this small part, okay? So I can see all my variables, all the columns, okay? But just just 6 rows, okay? Right? So something else that's interesting that you can also do is you can also subset by excluding indices, okay? By excluding indices, okay? For example, this first one here, okay? This first one, I'll type it again so that we're typing with you, okay? I want to see surveys. I want to see all the rows, so I don't specify, but I don't want to see column 1. So I say -1, okay? -1. So I want to see all the rows, okay? And because I've said -1, it will give me all the columns except row 1, okay? So 1 is the index for the first column, okay? Okay? So if I run that, okay? The first column, you can see up here that where we didn't is record_ID, okay? Is record_ID. But it's not here, okay? Because we have excluded it, okay? We said we don't want to see the first one. So we've only started from the second, which is month. So here we don't have the first column because we've excluded it using the -1, okay? So you can change and say we don't want to see the second one, okay? So you see, now what happens? We have the first one, but we don't have month, which was the second one. So that's also another way of subsetting your data set, okay? And again, you can also use the range, okay? So the range still works here when you're doing the excluding, okay? So here you said we want to see surveys, okay? But, okay, I want to see surveys, but I only want to see the first 6 rows. So this is the same as saying the first 6 rows, but you don't want to see, exclude, you want to exclude the range of 7 to 34,786. So remember, you have to work within the dimensions of your data, okay? So we want to give it a range. So I want to see everything except the row 7 to the last one, okay? And I want to see all columns, okay? So let's see how that works, okay? So you see, it gives me only the first 6 and excludes everything else, okay? And it gives me all the columns, all right? So we've seen that we can be able to specify or subset our data set using the coordinates, okay? You can use the range using the full colon, okay? And you can also use excluding indices by using the negative sign, okay? The minus or the hyphen. So the other way we can do is by calling the column names. You can specifically call or subset your data by calling that column name, okay? So if you have an idea and you know exactly how they've been written within your data set, remember R is case sensitive. If you misspell one thing, it will not find it, okay? So I want to see surveys, okay? For example here, I want to see surveys, okay? And box bracket, remember the box bracket is used for subsetting. And I only want to see species. I also hope I'm typing it correctly. Species_ID. Okay? I only want to see that particular column. So you see, it only gives me that column only. because I've only called that column. So what happens if I type this incorrectly? Say I misspell this. What happens? It tells me it can't find it. It can't subset the columns that don't exist. Column da 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 does not exist. So R is very case sensitive. All right. Okay. So if you want to call a column by its name, make sure you know the name. Okay. So you see the difference between this and the second one here. So here we only call the column. Here I want to see the column. I want to see all rows. Okay. All the rows. Okay. And we can also do that by using double braces. Okay. Double box braces. Okay. All right. So this one gave you the result, okay, with a single brace as a data frame, meaning you have row names and you have the column ID, okay, the column ID and all the values. So this is sort of like a table with just one column, okay, that's a data frame, okay. But if you use this double brace, okay, the double brace, the difference is that it gives you as a vector, okay. Let's see. All right. A vector meaning it just extracts all the values within species ID and spits them out onto your console. Okay. All right. So you could see the difference. This one, it gave you as a table, okay, a table, which is a data frame. But when you use the double column, sorry, the double box braces, it gives you as a vector. Like it's just a list of all the values within that column. It doesn't even tell you this is column da 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 or what, okay? It just extracts all of them and spits them out into your console or into your standard output, okay? So it tells you that it omitted this number of rows because the first 1,000 have been printed and these others are also there. It's just that it couldn't print. It only printed the maximum number that it could print on your console. Okay. So you need to be aware of what the different subsetting things or subsetting operations do or operators. So the box brace, one single gives it to you as a data frame. So it will extract it for you as a table. But if you just want the values, okay, if you just want the values, you get them as double quotes. Okay. All right. Okay. So the other way, which comes very much in handy, this one make sure you have it, is okay, is by using the dollar sign. Okay. So let me type that so that we're doing it with you. So if you do surveys and you type dollar sign, okay, dollar sign is on your number 4. So if you press shift and number 4, for the ones who I'm assuming you have the same keyboard, if you press shift and number 4, it gives you a dollar sign. And you see, once you press the dollar sign, it gives you a list of all the columns that you have. Okay. Let me do that again. It gives you a list of all the columns that you have. So you can select whichever one you want to see. Okay. You can select whichever one you want to see. You can select any of them. Okay. And if you call it, so for example, let's call taxa. So if you run that, it also gives it to you as a vector. Okay, it gives it to you as a vector, all the values. But this is important. It's one of the easiest way to look at. It's one of the easiest way to look at a column, any column within your data. And it's also the easiest way to get the correct spelling or the header of your column. Okay, so if you just call tab, the name, and then dollar, it gives you a list. So you can see all of them and you can actually choose the one you have. Okay, and it will type it correctly because it's actually just reading from your data. Okay, right? So that's also the other way to look at your data or subset your data. Okay. So there's also a challenge here, but I need to leave shortly. So Mike, is it, I think it's okay. Can we just skip this and you can do it over the break?
Yeah, sure, that's okay.
Unless we have any questions.
I think that's okay.
Okay.
Because of time, yeah.
Because of time. Okay. So because of time, I am going to go ahead. So we are done with subsetting. Okay. So now let's look at factors. Okay, let's look at factors. So in order for us to look at factors, let's call summary, or let's call STR on our data again, the structure of our data. Okay, let's call the structure of our data. Okay, so when you do STR on our data, right, you see the different types of how the data has been stored, or the different ways in which the data has been stored, numbers or characters. Okay, so R has a special class for working with categorical data. Okay, because when you're doing experiments, when you're doing experiments, you are categorizing your data into.
Bernice,
Yes.
I'm really struggling to hear you. I don't know if it is my gadgets or it's your volume is. I wish you could raise your volume a little bit.
Okay,
Thank you. That's fine.
thank you. So as I was saying, um, R has a special way of working with categorical data called factors. All right. And when you're working with different experimental data, you have treatments, you have reps, you have stuff like that, and you want R to be able to recognize that. So you want R to be able to recognize that several rows were observed to be treated or untreated, or to be under a certain, treatment or a rep. So you want to turn that into a factor. Okay. So factors are very useful, and they actually contribute to making R very well suited to working with data. So once we are able to create factors, they can only contain a predefined set of values. Okay. They are predefined because you already know what your factors are within a data set or within an experiment. Okay. So these predefined values are known as levels. Okay. So maybe you have nitrogen level 1, or you have a dosage for a group of trials, or a group of whatever you're working with at certain levels, at 0, at 1.5, at 2, and all that. So they are stored as integers associated with labels, and they can be ordered or unordered. Okay, so you can order them by decreasing or increasing value, depending on how you want to store them. So while factors look like characters, okay, because they are characters because you're typing them as maybe words or strings, okay, they're usually treated as vectors by R. So inherently, R will store them as levels, and they'll be stored as numbers, okay? So you need to be careful when treating them as characters or strings. So when importing the data, the columns in the context are not automatically coaxed into a factor, okay? So you'll see it's either a number or a character, okay? So R is not able to read which character vector is a factor or you're considering as a categorical data unless you tell it. Okay, so they are not automatically coerced or converted into a factor. But once you have loaded the data into R, the conversion can happen, and you can tell it which vectors you want to convert into, a factor. Okay, which vectors you want to convert into a factor. So for example, let's look at surveys. Okay, so when you look at surveys, we've seen that sex, if you look at my lower on the console, is stored as a character, and it has values M, N, A, okay, right? So I can quickly look at it by just calling surveys $sex, and it gives me all of this. So you'll quickly notice that it only has 3 values. It has M, it has NA, and it has F. So these are clearly categories of data. Okay, so we want to tell R, for me, this is a factor. This is categorical data. So can you understand it as categorical data? So we'll do that by reassigning the vector of sex as a factor. Okay, so if you just type surveys, okay, So if you type surveys $sex and then you reassign it as a factor. Okay, so I want you to, so I'm telling R, sorry. So I'm telling R that in surveys, this particular column, I want you to treat it as a factor. Okay, so in your console, you'll see that it worked, right? But it doesn't give you a warning. So you have to check. Okay, so it's always important to confirm that what you've done worked. So if we run summary again, and we run it just on that particular column that we've changed, we can see that now it gives you something different. It gives you F, M, and NAs. Okay, F, M, and NAs. To tell you that it was able to cover, or it was able to notice that I have 3 levels within this vector of F, and these are the number of observations within F that I've noticed that have F, and the number of observations that are M is this, and you have NAs. You have 1700 NAs. Okay. All right. So we can see that the conversion has worked, and we can see it produces a table of counts. Okay. All right. So what it does, okay, is that R will assign 1 to the level female, okay, and 2 to the level male. Why? Because levels by default are stored as, are stored in alphabetical order unless you order them differently, okay? So the levels within this vector, okay, so let's look at it. Let's see how they are stored, okay? So if you just type levels, this is actually a function within R. Levels, it's for looking at factors.
Bernice,
Yes.
the volume. Yeah, now you're back.
Okay, sorry. So if you look at levels, okay, if you look at levels of surveys $sex, you'll see how it's stored. Okay, so it stores them as F and M. Okay, and it is stored in alphabetical order. If you haven't ordered them, it is going to order them alphabetically. Okay, F and M, and F comes before M in the alphabet, so that's why it's stored like that. Okay, all right. So we can also check the number of levels that we have within a factor. Okay, so this was just to check the levels. Okay, but you can count by saying n levels of that vector that is a factor. You can count the number of levels that you have. So if you run this, if you say n levels of survey dollar, that tells you there are 2. Okay, there are 2, and you can see when we printed it here, levels, it started with 1, so it's 1 and then 2. Okay, so F is stored as 1, M is stored as 2. Okay, right, so that's what we are having here. Okay, so here is also another challenge where you need to look at the columns, taxa, and genus in the survey data frame and turn them into a factor. Okay, and then using the functions you've learned, you look at how many levels you have within there, and if there's a level called rabbits, how many of them were observed. Okay, so this is a challenge, you can look at it later. Okay, so we'll quickly look, before I leave, we'll quickly look at converting factors. Okay, converting factors. It's 10:23. Converting factors. Okay, so factors, we can convert them. Okay, so first of all, let's create a vector of levels called sex. Okay, with 4 values within it. You remember we did this yesterday. We used the C, that function with C and double brackets, to create a vector. Okay, and we want that vector to be a factor, so that's why we are calling factor outside. Okay, so sex let's just type it quickly together, is factor, and inside we want to have 4. We want male. Okay, remember to separate them using a bracket, a comma. We want female. Okay, and then female again. I keep forgetting this. And then we have male. Okay, have I typed that correct? Yes. So if we do that, let's look at the current order. I hope we're together. So let's look at the current order within that factor that we've saved, within that vector that we've saved. Okay, so it tells you it's male, female, female, male, and these are the levels, female and male. And of course, female comes before male because F comes before M in the alphabetical order. But we can reorder them, okay, and say we want the levels of the values within sex to be male first and female first. Okay, so we'll have reordered them. Okay, so let's type that together. As factors, all right, we want it to be, we want to change the value of the levels. So we want the levels to be, okay, give them as a list. Okay, 1, we want male to be first, and then second we want female. Okay, so let's run that. It doesn't give you any, but it has run without an error. There's no output, so let's check. Okay, so let's check again. Okay, so let's check the levels within it again. So levels of that factor called sex. So now it's male and then female. Okay, it's male and then female, right? So that's how you can reorder factors within your vector. Okay, so the other thing you can also do is you can actually change them into, you can change them back into a character using as.character function. Okay, you can change them back using as.character function. Okay, by renaming them like this. Okay, as.character function. So if you just call as.character, okay, if you type it, it will autocomplete as.character. For that, it will run like that. Okay. All right, so now it just goes back to being male, female, female, male, but I haven't reassigned it into anything. You can also reassign it back into the variable. Okay, yes, so I hope we are okay up to there. Okay, Mike, I think if you allow me, I want to stop there.
Okay.
Yes.
So yeah.
I'm going to inform Jennifer this is where I've stopped. So we only have just one more thing to look at. It's just the renaming factors, so she can start from there.
Yeah, she's actually online.
Okay, so Jennifer,
Yeah.
maybe if you can just start from here, renaming factors. That's the only thing we have, and then converting or formatting dates. So those are the only 2 things left.
Sounds good.
I think,
Thank you.
Okay. Okay.
What was it?
I thought maybe if we can skip the formatting of dates.
Yeah, I think skipping formatting of dates makes sense, and we'll talk about renaming factors, and then go on to like the beginning of the tidyverse or the dplyr section.
Okay, good. So
Bernice,
yes.
are you able to pick one question, or time is?
Okay, one. I can answer one. before I quickly
So
leave.
Ronald, please explain the repeated male and female. So this is in the chart.
Okay. So the thing is, we were okay. We were creating a vector and making them factors at the same time. So what I could have simply done is I could have first created the vector, okay, like this, and said C. Okay, let me just copy this. Be lazy a bit. Okay. Okay. So I could have first created the vector like that. So it's a vector of 4 values: male, female, female, male. Okay, that's what I could have done first. And then secondly, I could have just said, reassigned it by converting everything into a factor and said s dot, or said factor that. So I want it to be a factor, okay, and run it like that. So these are the two things I did, but I did it with one line. So that's why you have the repeated measures within it. Okay. So first I created the vector called with these values inside, and then I made them factors. Okay. So that's what I did. But instead I just did it in one line. But I could have simply done this.
Okay.
Yeah.
Thanks, Bernice, for your time. Yeah.
Okay.
And
Right.
yeah, we've taken 4 minutes of your time. Apologies.
No problem.
So I
let me
think
just
right
okay.
now we can have two options. Either we take a 10 minutes break, or Jennifer can finish the renaming of factors, and then so that we finish up with the lesson 3, then have the 10 minutes, and then we can start another thing.
Yeah, I think
Don't
that
know
sounds
what
good to
sounds
me.
okay.
Yeah, I think
So,
let's do the renaming factors and then we'll take a break.
yeah.
And then we'll start in a new section.
Okay. Bernice, you can stop sharing your screen.
Sorry. Yes, I stopped. Thank you.
Okay.
Bye.
Okay,
Bye-bye.
bye.
All right.
Okay. Let me just. Hang on one second, sorry. Okay, so just like yesterday, is the file size, is the font size okay for everyone?
Yeah, it's okay.
Okay. All right, so we are going to be starting on renaming factors. So in R, when your data is stored as a factor, you can use plot to get a quick glance at the observations represented by each factor level. So we're going to try just making a very basic plot of some of our survey data. And I'm actually going to have to catch up with you all a little bit here where I need to change this probably to a factor because you've already set it as a factor, right?
Yes, Susan just responded yes.
Okay. Maybe I can show what it looks like if I don't do that. So if I set this to a factor, okay. See, now it will plot for me. Oh, sorry.
Oh, I
I just
think it's
saw
the
in the
size of
comment.
the window. Yeah.
Yeah.
Just try to enlarge it or something, probably.
Mm.
The bottom right.
Right. Hang on one second. Sorry. Let me just get my data to where your data is. Mm. Actually, let's go ahead and take a quick break now. I just need to match my data to your data before we can start. So why don't we come back in 15 and then we'll pick up and then switch over. Does that sound okay?
All right.
Okay.
Okay.
So I'll
So,
see you all in 15 minutes.
all right. So that should be 11:03.
Mm-hmm.
No. 11:05.
Okay.
Okay.
All right. I'll see you then.
Excuse me.
Hello?
I think we should be doing some of those challenges we were given or something.
You want
Before,
to?
yeah,
Cynthia,
Oh,
but
we
the
can do
challenges,
challenges. Yeah, we can do challenges when we get back from the break.
okay.
But just take a
yeah,
break, take a break from
yeah.
the screen, walk around. I think for workshops like this, a lot of times it's good to get a little bit of a break from staring at the screen for too long.
Okay.
Yeah.
Thank you.
Hi, Sheldon.
Hello.
Yeah, are we set to resume now? I think, I don't know
Yes.
if everyone is here.
Yeah.
What time did I say we resume? Because
I think he said that we would still have a couple, like 5 more minutes. But we can take questions or we can talk about things if we want while we're getting set up. Or you know what, I could walk you guys through what was going on when I was trying to set the levels. I don't know if anyone guessed, but I could show you.
okay.
Okay, so okay, so before we left, I was looking at the data, and so I thought, maybe I'll reload because something was happening to the factor for the column sex. So if I hit enter on this, so I'm hitting control enter or command enter, depending on what kind of computer I'm on. And then that'll reload the surveys data. So it's fresh. And then when I was running a command that looked like this, the only difference between this and my command was that the command I was running, I was thinking we had male and female for the different levels, right? But if so if I tried to run something like what I had been running, it would look like this. Okay. All right. So when we look at the output of this, a lot of it is NA, right? A lot of it is essentially blank. So can anyone guess why that command made things essentially blank? This command? Okay, so the values here are like capital M and capital F, not male and female. So if I said, for example, just set this to a factor. So sometimes I'll just do little kind of test runs to see what we're looking at. And then if I check the levels of test, it's F and M, not male and female. So R was doing what I was asking it to. It was trying to set these as levels, but they didn't exist in the data. So everything just went to NA. So if I redo this, setting it to male and female, and then plot, then I get a plot that's like more readable, where I have the number of males and the number of females just automatically plot by R. And this kind of easy automatic plotting can be really useful for just taking a glance at your data, or figuring out if your analysis makes sense, right? Because I wasn't getting an error message when I tried to set it to the factors to levels that didn't actually exist in the columns. But it was, not plotting. It was basically showing me a plot where there was no data. Because everything had switched to NA. Okay. So that's the plot function, just as a quick cursory look at your data. And we saw earlier when we used summary for survey $sex, that there were about 1,700 individuals for which sex information hasn't been recorded. So that's common in public health data. Oftentimes when people go to a doctor or a health clinic, they will receive information about their privacy rights, and we should only take information from people if they consent to give it. So oftentimes you end up with data sets that have a lot of like NA values for different information that the patient may give to the doctor or the medical provider. So in this case, we might want to be able to see the number of people who didn't respond, who we don't have information for. That might be informative. So we can use a function called add NA. So that would look like this. Say sex and then use the assignment operator and then set it to add NA. And okay, so now I see a third column. I see an M column, an F column, and a blank column for the people who didn't respond to the survey. So that gives us an idea of what proportion of people in the survey responded to this particular question. All right, so now we come to a code challenge. So we're going to try to rename F and M to something more useful, to like maybe useful is the wrong word, but something more human readable. So oftentimes in our data sets, we get something, that's like sometimes gender or sex will be coded as like 1 or 2 or something that's not very readable when you look at a plot in like an article or in a report or on a poster. So you may want to rename those. So the challenge is going to be to try to rename those. And just as a hint, so I can take a look at what the levels are, right? If I say, for example, levels for sex, then I can see I've got M, F, and NA, right? So how would I name index 1 and 2 in this kind of vector of levels for this factor is the question. So I'm going to post the code challenge now. Okay, so on line 548 at the bottom of the HackMD page, you can see the code challenge. And the goal is simply to rename F and M to female and male respectively. So you want to use that assignment operator to rename F and M to female and male. Now that we've renamed the factor level to undetermined, can you, and then you want to try to rename the NA column to undetermined. And then can you create a bar plot where you've reordered things so that undetermined comes before female?
So we give it how many minutes?
So let's give that 10 minutes and then we'll discuss.
So maybe 1 minute to ask whether people are following.
Yeah.
With the challenge and
Feel free to ask out
understood.
any questions about it.
Okay. Everyone is missing. Okay. It's line 50. Line 550. Oh, sorry.
Yeah. It's at the very
550.
bottom.
Are we okay to do the challenge? Is everyone
Yes.
following?
And does anyone have any questions about the wording or where to start? Or if we just give that a shot, think about it for a little bit, then we can work through it together.
Okay, I think silence means we're following. So now it's 11:11, so 11:21.
Let's do 11:20 and then we'll
All
meet
right.
and talk about it.
Okay.
And here's a hint. So if I wanted to rename NA to undetermined, then I would do it like this, right? So we know levels is a vector. It's a list, right, of the different levels. And the third one was NA when we looked at it. So if I did this, and then I said plot, now I see undetermined here rather than just blank for NA. So how can you do the same things for the first and second? And if people feel like they have successfully done this, then could you just type yes into the chat or finished? Thanks, that's good feedback. You can keep playing with it a little bit and we'll be talking about it in a few minutes. Oh yeah, that's a good idea. We could talk about it. So I'm just putting backticks around that to make it a code block so that it's a little bit more readable.
Yep.
Okay, so yeah, so we can rename this like this. So what we have here is like we know level, survey sex, item 3, element 3 in the like list of elements was renamed undetermined. So I showed you how to do that. And then for element 2 for male, you know, we did that manually here. And for element 1 for female, we did that manually in a similar way. What would I do if I wanted to rename like 1 and 2 at the same time? Can anyone show me what that should look like? So if in one line I wanted to rename levels from survey sex 1 and 2. What I'm like basically thinking of is we'll rename a vector, like a short vector, with another short vector. So how do we take a slice of levels from 1 to 2? Does someone want to walk? Is that Ronald typing?
No, it's another person posting the answer.
Okay. So does one of the participants, one of the attendees, want to walk me through how I would write the levels from the first to the second, like a short vector? How could I take that slice? So I'm going to put a line here. So how would I make this a list of the first two? Here, I can do it here. So I've got levels of survey sex, M and F here. Levels of this would M, F, and undetermined. So if I wanted to take the first two, then I could use that from to notation, slice notation. So I could say 1, 2, right? So if I wanted to, I could rename both of these at once by replacing this short vector of 2 items with another short vector of 2 items. So I could say levels of sex from 1 to 2 are going to be reassigned using the assignment operator. And if I want to make a short list, a short vector, I'm going to use what function? It's a single letter is the name of it. Does anyone remember what function we were using to make lists of things? It barely even looks like a function. And whenever I see it, I always think it's the C combine function, because in my head, I have to make it longer to combine to remember, what it is that it's doing. But it looks like this, and it's really just a function call, just like levels is. But it's very short, like the spelling of it is very abbreviated. This just means combine, like combine into a vector. So I could say, instead of M and F, I want like male and female. Okay. So then if I looked again at what this was, I would see male, female, and undetermined. So I can rename these one by one, or I could rename them as a list, right? As like a vector of names. So that's just nice when you're working with like larger data sets. It's nice to be able to work that way rather than doing, each one individually. All right, so just as a wrap up for this section, I'm going to show you all an example of someone trying to manually make a data frame, and we're going to try to see if we can spot any errors in it together. Okay, so we use read_CSV to create a data frame, but you can also like hand create a data frame with a function called data.frame. And when we take a look at this function, They're using C combined to make vectors, and then they name those in the function call. But there are some problems with this. So up here is this person's command. And you can see already that because we're working in RStudio, I'm getting these red X's here to show me that there's some lines that have errors. So does anyone want to maybe point out which things are potentially errors and see how we could fix this? So you can see we call the function data frame, and then we pass it the name of a column, and then we pass it like a vector that's going to go inside of it. So if anyone sees any issues with making this into a table, like a data frame, where you have, you know, a list of equal length vectors that are all the same type of object, does anyone see any problems with this call? Line 31 is missing quotes. Yes, exactly. So dog with it without quotes, then R is going to try to interpret that as like a vector, and it's not, right? So it's not going to know what we're talking about there. Lack of double speech marks on, yes, exactly. So yeah, we want to put those double quotes here. Okay. "33 is missing a comma after 8. Yes, so right here. And so that may be the source. And see, you can see there's an unexpected token 1.1. So what they're saying is, like, I see 8 in this, you know, argument that's supposed to be like a list of items to add to a vector. But I don't know why it's followed by 1.1, because it should be followed by comma. All right, great. So I think there may be one more issue here. So to test that, I'm just going to try to run this and see what kind of errors we get. So does anyone want to try to interpret this error message for me? Even just a guess, and you don't have to type it in the chat. You can just say what you're thinking may be the problem here. So the main error message is arguments. Yes. Some rows have 3 columns. So some rows have 3 rows. It looks like rows here, right? But these are going to become the column. So this is going to become the column name. And so some of these in the table would have 3 rows and some would have 4, which is just not the way a data frame works. So let's just get rid of this one. Let's make it easy on ourselves and just delete one, which obviously we couldn't do with real data. But now we could highlight all of this and try to run it, see what R says. Let's see, 1, 2, 3, 1, 2, 3, 4. All right, so that way we could use our error messages to debug our work. And that happens a lot where you're debugging something, you know, kind of in a stepwise fashion, where you fix one thing and then you get another error message and you kind of work out from there. So here we can see we wrote it like this, so it looks like these are the rows, but really animal, feel, and weight become the column names. And the rows, you know, just become what order you were, what number you were in this list of vectors. So cucumber, cute, spiny, and 1.1 become the last row in this data frame. Okay, so one more quick one. Okay, So we may not even get this one to run, but I just want to see, does anyone see any issues with this one right off the bat? So the definition of a data frame, it needs to be something where you have, you know, an equal number of rows for every column. All of the columns are vectors, and vectors can only contain the same type of object. Does anyone see any issues where this one isn't producing any red X's? It's not like we're missing commas or there are a different number of rows. There's nothing wrong inherently about this. R will accept this, but it may not make the kind of data frame that we want. And can anyone guess where a problem might come in?
On line 39, where there's a temperature, 15 is has been indicated as a string.
Exactly.
Yeah.
And someone else pointed out on line 40 that false is in quotes here, right? So R would probably change this whole column to strings instead of, and this whole column to strings instead of integers. So that's not going to work. Whereas this should probably work because 0 and 1 can usually work as Booleans. So we would want to take these quotes off. And this, I don't know if you have done wet bench lab work, you know, where you may work with a data scientist, and they seem like they're real sticklers for like the way people type things in, but this is like the kind of reason why. Okay, so then if we take a look at this, okay. So kangaroo has converted to numeric, so we don't want that. So we'll say this is true. And then rerun. So this is kind of the way that you usually are going to want to work, where you, you know, write your code incrementally and debug incrementally and confirm that everything is coming out the way you want it. And that's part of why it's important to oftentimes work with like the smallest version of your real data set that you can. Because with a very small data set like this, you know, we can make sure that everything is working the way that we expect it before we scale up to like a full-size data set, which are often too large to be human readable. Okay, so that's the end of our section on getting started with the data. So we're going to pivot and start to learn about dplyr. And so dplyr is a package that provides easy tools for the most common data manipulation tasks. And it's built to work directly with data frames. And it's been, and many common tasks that people want to perform on data frames has been optimized with it. And an additional feature that it has is that you can work directly with data that's stored in an external database. So one thing about R is that it's set up to run all operations in memory. So you can imagine that as your data set gets larger and larger than these like comma separated values files we've been working with, that can become a problem if you're working on like a laptop or a small cluster or someplace where you don't have access to a lot of memory. So it's a real feature to be able to work with external databases, because then that external database can store most of the information. You can query it and just get back the kind of slice from their data that you're interested in. So the database connections essentially remove the limitation that you can't connect to like a database of many hundreds of gigs to conduct queries on a machine that doesn't have that much in the way of resources. So this morning, we're going to take a peek at some of the common dplyr functions. And when I say dplyr, it's actually spelled like this. Okay, so their common functions include things like select, to select a subset of columns, filter, to filter a subset of rows on conditions. So if we want to say like find rows that, you know, where weight is greater than 10, right? So that would exclude these two. Mutate is going to create a new column. I always think that name is like a little, it doesn't really tell you, it doesn't bring to mind what it does in my head. But when you see mutate and dplyr, think I'm going to create a brand new column of information from other columns. And then there's group by and summarize, which allow you to create summary statistics. So if you wanted to know, for example, weight of all sea cucumbers, and then arrange to sort the results, and count to count discrete values after you've, like, for example, grouped them. So we're going to get through some of these this morning, and then we're going to pivot to plotting. Okay, so some of our learning objectives are going to be to do things like select certain columns in a data frame with the dplyr function select, and extract certain rows in the data frame according to a logical Boolean with
Excuse
the
me.
dplyr function filter.
Are we supposed to also see your, do you have, maybe you're showing a presentation or something?
No. I just wanted to kind of walk through the basics of what dplyr is, and now we're going to start like working through examples of that.
Okay.
So we'll try using select to select a few columns. So for select, the first argument is going to be the name of the data frame we're working with. So this is the start of the dplyr section, and we're going to call select. And we're going to pass it the name of our data frame, which is in this case surveys. And then we want to pass it columns that we're interested in. So let's say like plot ID, species ID, and weight. So here what we got back was like a small data frame with just plot ID, species ID, and weight. So this is similar to yesterday when we were looking at things like notation like this, where I might say, well, this is similar to where we were using column names to take a subset. So here's one way to get plot ID, species ID, and weight. In dplyr, the notation would look different. So it would be like select, and then the list after we list the data frame that we want as input. Okay. To exclude a column, we're just going to put a minus sign ahead of it. So let's say we wanted to see surveys, but we wanted to exclude record ID and species ID. Then it would be like call select on surveys, and we put like minus record ID. So if I just execute that, then I'd see all the columns just without record ID. And I could add species ID. I could add like a list of, you know, whatever else I was in, wanted to exclude. So this does the same thing as the notation that we learned yesterday. But you can see once we get to more functions for dplyr, that this is part of a large package that is pretty powerful when you combine the different functions. Okay, so to choose rows, this is how we would choose columns in dplyr. So to choose rows, we're going to use filter. So we could say filter the dataset surveys. So that's the first argument. And we could filter it for where rows where year equals 1995. Okay. And so we can see the data frame that we get back has year all set to 1995. Okay, I could set it for greater than, I could set it for, you know, greater than or equal to, or not equal to. Okay, so then I get any row that is not 1995. So that's how we choose rows. And then we've learned how we choose columns. And so you see already that that filter is a lot more useful than saying being able to select based on the index of the row, because I don't necessarily know in advance which index correspond to the things that I'm interested in. So this is basically creating a Boolean for like true false for whether or not they equal 1995, and then using that to filter out certain rows. Okay, so we can pipe this type of call together. So there's different ways to kind of string select and filter together to create the data set that we're actually interested in interpreting. So we could do that with intermediate steps where we create a temporary data frame and use that as input to the next function. So that would look like this. So we could say like surveys 2 is going to be the output of filter to surveys. And I'm going to pick call a rows where weight is greater than 5. Okay. And then I could take surveys 2 and create surveys small. And I could select from surveys 2 for the column species ID. Okay, so I could do that.
There's a question in the chat box. Is filter only used for numeric data?
No, it's not. That's a good question. So let's take a peek at surveys. Look for a different column that might be useful. So taxa, for example, let's see what that looks like. Are they all rodent? Okay, so the levels for this, like the unique values for this are, which I got looking, running factors on taxa, are bird, rabbit, reptile, and rodent. So I could say, for example, let's write a filter. So let's say filter where taxa equals bird. So here I've been able to select for rows where the taxa is equal to bird. Okay, so we did this process where we made an intermediate data frame called surveys 2, and then we passed surveys 2 into a select for certain columns. And so then what we ended up with was one small surveys that was selected for animals with a weight greater than 5, and the column species ID, sex, and weight. So that, can take up multiple lines. Another way that we could have done that is like nesting. So we could say, for example, I'm going to take this line. And then I'm going to nest this first command in here. So instead of pointing to surveys 2, I'll just do this. And then run it. And I actually get the same result as I did before. But this, you can kind of see it already is becoming a little bit difficult to read, so for me to glance at that and see what it is. So this intermediate workflow, has the kind of disadvantage of creating all these data frames in memory. So each of these exists in memory, but it is more human readable. This doesn't create like unnecessary intermediate data frames, but it's less human readable. So one of the advantages of dplyr is that it kind of is the best of both worlds. It's readable and it doesn't create those intermediate data frames, because we can use something called pipes to pipe the output of one filter step into another select step, or vice versa.
Jennifer,
Mhm.
maybe you could explain a little more about what really nesting is. Maybe I missed
Sure.
it.
Yeah, and so
'cause-
we've been seeing nested commands for a while now, but that's a good question. So every time we use like the C combine command inside of another argument, right? So here, for example, we were creating this data frame and we were using C combined inside of this function called to data frame to create a vector. But we could have, created this vector and name it like animals vector, feel vector, and weight vector in separate lines, and then just put in those variable names here. But instead we nested that function call inside of another function call, so that we didn't have, fill up our code with all of this extra memory, objects in memory that we don't really need. So that's an example of nesting. Here's another one. Here we go. When we were making factor calls, this is nesting again, because we're using C combine, the call to that nested within this call to factor. So I'll just come down here and I'll show, this is the nested version. This is not nested. Okay, so I could say like new levels. And then I could do this factor call with new levels. Does that make sense? So I either have this thing where and R is going to always interpret this from what's called like the inside out. So it'll find the innermost function call and execute that. And then it'll execute the function call that's wrapped around that. And if this were part of something bigger, then it would, interpret the thing that's wrapped around that. But there's no nesting in this one. You just have new levels defined, and then new levels is passed into this factor call.
Yeah, I was actually asking on behalf of novices in R.
Yeah.
Yeah.
Okay. So that's nesting. And while it can be useful, it can become unreadable fairly quickly. So you could imagine if you had like things nested inside of nested inside of nested, all of a sudden, yeah, sure, R may be able to interpret it, but it's hard for you to tell, what order they're going to be interpreted in when you're just glancing at your code. So for readability, you might want to try something like pipes with the dplyr package. So the last option that we're going to talk about today is pipes. And that's actually a recent addition to R. And they let you take the output of one function and send it directly into the next, which is useful when you need to do like many things to the same data set, which is going to be common in data analysis. And in R, a pipe looks like a % greater than %. And so there's actually a quick key to be able to type that because it's a little clunky to type. So in RStudio, you can type Control-Shift-M on a PC or Command-Shift-M on a Mac. So that would look like this. So I could say Command or Control-Shift and then M. And this is what a pipe looks like in R. I'm just going to make this a comment line because I'm just defining it. Okay, so a simple example of piping would be to pipe select into filter, right? So we could start with surveys and we could pipe that into filter maybe, and then pipe that into select. We could do it that way too. So I'm going to start out calling surveys. And then I'll say Command-Shift-M as a pipe. And then I'm going to start a new line. You notice it doesn't start back at the beginning of the line. It gives me a little tab there to show that I'm in sort of this block, this like piped block of code. Then the next thing I can call is filter. And I can skip defining the first argument, which is what's the data frame, because I'm using a pipe now. So it already knows it's getting the data frame from a pipe. And I can just say, I want to look for rows where the weight is less than 5. So let's look for small animals. And then I can hit Control-Shift-M again, or Command-Shift-M on a Mac. And then I can say select. Species ID. And now I could just pick the columns I want, like sex and weight. Okay, so now I could highlight all of these and run them. Okay. So this gives me the same results as the previous two things that I was looking at. So this gives me the same results as doing this intermediate workflow version or the nested, but it has the readability of the intermediate workflow with the kind of lack of, memory hogging or excess memory consumption of the nested approach or of the intermediate approach. So does anyone have any questions about like how this piping concept works?
Jennifer,
Yes.
just hold on there. I'm trying to copy what you just did.
Yeah. Take your time. So originally we would do a function call to filter, and then the first argument would be the name of our data frame, and then we would say comma, and then pass in the conditionals, the like rules that we would use. Now the second line, when we were calling it individually, the first argument would be the name of the data frame that we wanted to work on, like surveys. And then the following arguments, all the following arguments would be the columns that we wanted to see. But now that we've used pipes, what we're doing is taking the full data frame, filtering for weight less than 5, and then that filtered data frame now gets piped as input into select, which then selects for the column species ID, sex, and weight. But it's all happening in basically like one argument. It's written on 3 different lines for readability, but I could write this all on one line and it's executed all together. Okay, so someone's asking, what's the best way to undo a code? I think I accidentally named all the entries in sex column to NA. Okay, that's fine, and that'll happen. And I think for this workshop, the best way to undo it is to read that CSV file back in. So you would want to do your read_CSV command again. So I think that would look like surveys would be read_CSV. And for me, it would be data raw. For me, it's portal data joined, but it may be something different for you. Or if you had trouble with that, then you could use the file and import data set to get the path to your data. And then you could rerun these commands. But don't worry about it too much for the purposes of our exercise. It doesn't really matter if that column is all NA. That's just the answer to your question of how you would revert after accidentally renaming something. And this is actually one reason why you always want to keep in mind that when you're working on real data, we have, for example, this data raw directory. You never want to edit your raw data. You want to import your raw data and then edit it, and then you can write it out. You know, you can write that CSV out to like somewhere else, like your data or your output directory or something like that. But you never want to try to, you know, make changes and then save them like in the same spot as your raw data came in. Your raw data, you know, you get it from the team that's doing the surveys, you get it from the sequencer that's making the sequences, you get it from the machine that's making measurements, and then you never change that file again. That file is what you call read only. And you can actually even look up something called permissions, file permissions, where you can set it so that the data, that the file cannot be written to, it can't be altered. And that's exactly why, because when you have a problem with the data while you're manipulating it, the only way to revert to the original oftentimes is to read back in the original. That was a great question. All right, so has everyone had a chance to write down this command and run it? And did anyone have any errors when they ran it? It worked. It just worked. Yeah, okay. Okay, great. All right, then we're going to make a challenge where we're going to try to use pipes and subset surveys data according to like a different set of selection criteria. So I'm going to post that. And then after that, we're going to move on to plotting. Okay, so for this challenge, it's at the very bottom of the HackMD document, and you're going to be using pipes subset to subset the survey's data to include animals collected before 1995 and retain only the column years, sex, and weight. So you want to make a new subset for animals that were collected before 1995 and retain only the columns year, sex, and weight. And so let's not write the answer for this just yet. But yeah, it's good to set the code block there. But we're going to take maybe 5 minutes to work on this ourselves, and then we'll come back together and talk about it. Does everyone feel like that's long enough, or should we take 10 minutes?
Jennifer, do you mind repeating the question again? I didn't get you clearly.
Yeah, sure. And it's on the HackMD document at the very bottom of the page.
Okay, let me check it out there.
Sure. I'll just repeat it to you while you're looking it up, but we're going to use pipes and subset the survey data to include animals that were collected before the year 1995, and we're only going to retain the columns year, sex, and weight in the final output.
Okay, thank you. That's clear now.
Mm-hmm. Okay, I think we'll go to 10 after. So we'll give ourselves like 8 minutes to work on this, and then we'll discuss. Okay, so how did that go? Does anyone want to try to walk me through the result? And someone saying that you load library tidyverse. Yeah. So to work with dplyr or anything in this kind of package, you're going to load the tidyverse library, and that you do that every time you run. So that's not something that happens, you know, it's not like install packages where we only do that once and then it's installed. Okay, so the challenge was using pipe subset surveys data to include animals collected before 1995 and retain only the columns year, sex, and weight. So does somebody want to show how to type that out?
Jennifer, like you want someone to explain?
Yeah, if anyone wants to jump in with like what's their first step when they're going to use a pipe and they want to pipe in the survey's data, what should I start? You don't even have to explain exactly, but just give me like a starting point. What should I start typing for my pipe?
Okay.
So if I want to pipe the data set from the data set surveys, what's the first thing that I would start typing?
You'd first type the name of the data set, surveys.
Exactly. And then what's the next
Then
thing I
the
would?
pipe.
Yeah.
The pipe
So I'm
symbol.
going to do Command Shift M or Control Shift M, and then I hit Enter. So
Yeah, and then
then I
the
want to
next.
filter, right, for the year 1995.
Yeah.
So how do I start typing that?
You'll do filter, then the brackets.
Then yeah, we do parentheses. Yeah.
Yeah. Then you'd filter for the year by typing in year.
Mm-hmm.
And then putting in the less than sign. 1995.
All right.
Yeah.
And then I want to send that to select because I want to select certain columns. So how do I
Yes,
finish
so
this?
you put in the pipe symbol again.
Exactly.
Yeah.
Okay.
And then select. Then the parentheses. Then year, 6, and weight.
Great.
Yeah.
And then I'm going to highlight all of this together to execute it. There we go. So I'm getting a subset that has weight less than 1990 or years, sorry, less than 1995. So we're seeing things from like 1970, which makes sense. And we're only getting certain columns, year, sex, and weight. All right. So now that we've done this, we're going to transition into plots again, but we're going to be using like a special package for plots. So ggplot. So to start out, I could say library ggplot2, just to make sure that's loaded. ggplot2 is a very popular mapping, or a very popular graphing package. And we are going to use some complete surveys data, so some data that's already been parsed, and using things like filter and select and some additional dplyr methods. So to load that data, we're going to actually download it off of a site called GitHub, where we have a free copy of it available. So if you look at line 352 towards the top of your HackMD, towards the top of your HackMD page, there's a line to define the ggplot dataset. Looks like this. So I just want everyone to get a copy of that line. Try not to delete it, and you can take the whole thing. So even where it's like, you know, naming, so we've got the assignment operator there to assign it that value. Okay. So I'll put that in myself. So now we've defined ggplot dataset as this URL. So this is going to a raw. So you can see there in the path, it says raw CSV file that's stored on a website called GitHub. This is just a place where people often share their code. And for small data sets or small metadata sets, it's also a good place to share that with your code. But you know, oftentimes we are downloading existing data sets off of the internet. So if we did something like that here, we would be using a command similar to the one you're going to see in a second. So we're going to use download file on the ggplot dataset, and we're going to give it a destination. So I'll say download dot file is the function I'm going to run. And I'm going to run it on ggplot dataset. And the destination, the dest file, I can set equal to, I want it to go into my data directory, like my output data directory, and I'll call it surveys underscore complete dot CSV. So I'm going to execute these lines. Okay, and so I can see I downloaded 2.7 megs of the file. So now I can use read CSV to load this data. So I can say, I'm going to call this surveys complete. And I'm going to load it with read CSV.
Jennifer,
Mhm.
maybe a little bit slow so that we confirm people have downloaded, because
Sure.
yeah, somehow they get lost when they don't have.
Yeah.
And maybe the destination, the data will be different for us because we already have a folder called data raw.
Yeah, we have a folder called data raw. Did they create a folder called data?
Mhm.
They did?
I don't, no.
No, okay.
So they
So why don't we
actually,
use data raw then?
yeah.
So I'm going to change this to data raw, data underscore raw. Let me just change this so that everyone can see. Okay, so when you've completed these steps, you can say like done in the chat. And if anyone's having trouble, also mention that in the chat so that we can help. We're just defining ggplot dataset with that URL to the file. And then we're running the function download file and giving it a destination file. And then we're going to read that in as surveys complete. And in fact, if you're having trouble and want to catch up, I'm just going to go ahead and paste this whole block in there. So each of these commands is now written in the HackMD document up towards the top. I don't know if you all can hear that, but my cat is actually snoring in the background. So I apologize if that's noisy. And if anyone has any questions about anything we've done so far while we're doing this, or what these commands are doing, things like that, let me know. So we are copying and pasting code right now. And I just want to mention that you see these quotes in my code here. They're what we call like straight quotes. So sometimes when you see double quotes like this in a text document, they look curled. So if you're copying and pasting code into something that's not a plain text file, then sometimes you'll get those curled quotes. So if you're copying and pasting code and getting errors, you may want to try to delete and replace these in your editor like RStudio and they'll probably go from the curled to the straight and will work again. Oh yeah, so the warnings, that probably just means that there's an extra column that like there's something a little offset about the data set. We're not going to worry too much about that now for the plotting, but one thing to remember is that that's a warning, not an error. It's just telling you that if this were a real data set and you were really doing a project, you may want to go back to your original data and see if you had like an additional column, or maybe your column names weren't lined up with your rows, or sorry, your column names weren't lined up with the actual columns or something. So something's going off a little bit there. So that probably means that your input data is a little bit corrupted and that you want to go back to it and see what's going on. Okay, so is anyone still working on the download?
Yes.
Are you having any particular questions or seeing any messages that are concerning? Warning messages will just mean that the command executed, it didn't fail. It's just trying to alert you to the possibility that there's something that you want to be aware of. So when you see a warning, it's just remember that it's different from if the program tells you error or failed. you may want to look into it, but sometimes you just, sometimes you get warning messages that you're not concerned with. Sometimes it's like this, where like, if I were really going to try to publish this data, I would probably open the input data and see like, oh, okay, are the column names lined up correctly? Do we have anyone continuing to download the data? Okay, I don't hear anyone working to download at the moment. So we're going to try making a plot with this. So ggplot, when we do a function call to that, the first thing that we pass in is the data, right? So that's the first argument, just like when we were looking at filter or select earlier. So in this case, the data that we're going to pass in is surveys complete. Okay. So if I execute that and check my plot window, I get a big blank box, which is exactly what should happen. So it basically just said, all right, I'm creating a plot. I have my data set, but you haven't told me, what are the axes of this plot? You haven't told me, which columns to plot. So to add layers to this, we're going to kind of build up and add different layers of information to this base plot. So I'm going to add a mapping layer, which uses an aesthetic function call. So this is going to be like a nested function call to something called AES. And that's going to allow me to select the variables that are going to be plotted on the X and the Y axis. So I'll say comma here, and then I'll say mappings. Mapping equals, and then this is a nested call to AES. And I could say the argument X equals weight, and the argument Y equals hind foot length. Okay, so now my blank square has gone to being kind of filled out. It says hind foot length on the y-axis and it says weight on the x-axis. It still has nothing inside of it, and that's because I haven't told it, like, do I want a scatter plot? Do I want a bar plot? I haven't given it any of that kind of information. At this point, since we were talking about nesting earlier, I just wanted to kind of take a quick second to reiterate the basic syntax of a R command. So in R, typically I'm going to call my function. In parentheses, I'm going to pass it a comma separated list of arguments, right? So I could have, arg1 equals blah. arg2 equals 14, right? So this is the syntax that we see again and again, right? Function, the name of the function, and then in parentheses, a comma separated list of arguments. And sometimes those arguments are named, and sometimes they're just taken in the order in which they occur in the help documentation. So for example, for ggplot, the help documentation would look like this. So the first argument is data, just like it was for select or for filter. The second argument is mapping. So sometimes when you see ggplot commands, this won't be named. It'll just be listed in that order. Just like here, we didn't name the data, but we could have. We could have said data equals. But since we didn't name it, the ggplot will just say, all right, well, what's the first argument in my help menu? That's data, and it'll go with that. So you'll see me, oftentimes I like to type out the name of the arguments because I think that's more readable for myself. Sometimes you'll see people just list them in order. Both will work. as long as you remember the order, memorize the order. So this works just the same as it did when I didn't name data. Okay, so we have our mapping, our X and our Y defined, and we have our data set defined. So then we can add what are called geom functions. So ggplot uses functions and to kind of add layers like I said, like scatter plots or bar plots on this these axes that we've created with mappings. So these geoms are going to be graphical representations of the data in the plot. And so you can think of, points, lines, bars as different ways to graphically represent the data. So geom point is a way that we could do scatter plots. So let's try adding that. So I'm going to do this with adding a plus to the end of this line and then hitting enter. And then I'm going to say geom point. I'm not passing in any arguments, but it is a function call. So I'll just put a little parentheses, an empty parentheses after that, because that's our normal, typical R syntax, right? We have our function call, and then in parentheses, our comma separated list of arguments. If we don't have any arguments, then it's just an empty parentheses. And in ggplot, it's important that this plus sign be separating these geom functions from the original so you always have this plus sign at the end of the line, and it's always going to separate the original call to ggplot from the geom functions. Okay, so now if I execute this, okay. Okay, and so what I'm doing here with hitting enter is I'm just trying to kind of make this data as readable for you all as possible to keep it all on one screen. And I actually don't just do this kind of, enter to separate these comma separated arguments, for example, right? So I'm hitting enter after the comma to separate these into different lines. And you can see that the tabs, the spacing is being handled by our studio. This is also the way that you want to try to write your code, because it's more human readable. If I have like this whole line written out as one long, string of information, it's difficult for me to see the individual blocks of code. So you want to do this kind of like code wrapping that keeps your lines no longer than about what you see here on the page. Okay, was everyone else able to create this point, the scatter plot? Great. All right, so let's try something different from a scatter plot. Or actually, let's try. Let's try modifying this. So when I'm taking a look at this, I can kind of tell a little bit where most of the points are falling, right? But I can't necessarily tell, you know, is this denser here or is this denser over here, right? Like everything goes to like inky black, and I can't tell the difference between like 2 dots stacked on top of each other and 1,000 dots stacked on top of each other. So what I can do is start adding arguments to geom point. So I could, for example, say alpha equals 0.5 and then rerun this. And then you start to see how this alpha has changed it so that some things are a little bit clearer. I still can't really tell, right? Like there's still a lot of this that just goes to inky. So I'm going to make this a little bit lighter. So maybe try alpha going to 0.2. Okay. And yeah, so for the question, does it exclude missing data? Yeah, it can't plot missing data. So it won't be able to plot, you know, weight if it hasn't been recorded, for example, because it wouldn't know where to put the dot relative to the x-axis. All right, so this is getting better, right? So when we first started out, I couldn't really tell that there were animals, for example, with a hind foot length around 35 here that tended to have a weight between 100 and 200. I don't know if that's kilograms. I don't know what the units are here. So I can kind of tell better from this where the density really is. I'm not confused into thinking like this area, for example, where there are not a lot of points, but there's enough when they're fully opaque to look the exact same as a more dense area like this. You know, I could keep going with this, but oftentimes when I'm plotting, I'll use alpha to make a scatter plot like this more readable, so I can see like really where are the dense areas, you know. So like this would look equally dense to this if we hadn't set the alpha. Okay, and then we could try, say, for example, setting the color. So if we were going to use this for a publication, we might say something like color equals blue. Or I like this one, Dodger blue. It's a sports team. I do not know for what sport, but I think the color is nice. So there we go. What's that? Baseball? Okay. We could have also just said blue. You can look up colors online, you know, that you can use in R. There's like a wide range. And then we can also say split it out so that we can see different species by color. So I'm going to do a nested commands here. And instead of specifying that all of the colors are going to be blue, I'll say I want to do AES for just this particular geom function and set the color equal to species ID, right? So that makes sense. We want to see for each species because it looks like we have some clusters here, right? And sure enough, right? So, and we have a key on the right here that tells us which species are which color. It's a little light because I have that alpha set very light, you know, but I could play with that to get it so that I could easily tell which species ID is associated with which color on here. And so this makes sense, right? Like animals of the same species are probably going to have similar hind foot length and a similar weight, you know. Maybe this animal here has a stable hind foot length throughout its life, but its weight fluctuates from 100 to 200 pounds. So maybe it just gets, I don't know, taller rather than larger hind feet. Other animals don't have as big of a range of weight, like these smaller ones down here. So you can see very quickly how we start to build a plot that we could use in a publication, and how, you know, we can use the fact that all of our data is in a data frame to be able to pick out particular elements that we're interested in, like the species ID, So ggplot is a really powerful tool for this. So let's try. Let's try like a super quick application of faceting. So I'll just say, let's see what's in this survey is complete. Just want to take a quick glance at this. Okay, so we've got genus here. So let's try faceting this by genus. So I'll say plus. Okay, so this kind of makes sense when we look at the genus, you know, so the animals of the same genus seem to kind of cluster close to each other in terms of their hind foot length and weight. So you can see how we can use the data structure here, like the columns that are filled with useful information and categories that we can, you know, convert to factors to do things like facet our results if we want to, or plot them all together, like we did up here with just splitting color, changing the color by species ID. So I think you can start to see how powerful ggplot is for producing publication quality plots. And I think you'll notice, like, as you look at scientific publications, that a lot of the plots in it were made with ggplot. And we're actually coming to the end of our time for the day. Do I have that right, Mike, that we want to pivot to doing the survey?
Yeah, sure. You do
Okay.
want to show box plot?
Yeah, sure. We could do a box plot. And so we're going to share information with you too, you know, so we did geom point here, but like I said, there's also a geom box plot, geom line. In addition to geom point, there's like lots of different options for like the graph, the visualization that you can use for this. So let's try, we'll create a new one. And let's do species ID and weight for the AES for this. So I could say my mapping is going to equal AES. And for X, I can do species ID. And for Y, I could do weight. And then I add a plus at the end of that and hit enter. If I don't do plus and enter, oh, sorry. Let me close this. Then I hit enter. And if I don't do enter, then I'll get an error. It has to, this has to be the very end of this line for this kind of notation to work. So then I can call, instead of geom point, I can call geom box plot. Okay, so everyone's, I'm sure, familiar with a box plot where you have the median indicated here and you have the outliers indicated, right? So this is a very useful way to visualize data. And you can see without very much work, you can get a very high quality version of this box plot. I could also say like AES color equals I mean, in this case, it would sort of have to be something like species ID, which seems a little redundant, but I think sometimes it does make the plot more readable from a distance. Right? So I can also add a jitter. So I can do layers of different visualizations on top of each other. So I'm going to add plus to this. And I could say called geom jitter. And say alpha equals like 0.3. Okay, so that, like my box plot, becomes less readable there. So I could just even make the box plot disappear, you know? So maybe I would decide to have in the paper two plots, like this jitter plot, which is kind of like the scatter plot we saw earlier, but instead, you know, arranged in these sort of columns by the categorical x-axis. So I could say alpha equals 0. And maybe so I could visualize this as a jitter plot, as a box plot. Earlier, we saw a geom point scatter plot. We saw that we could use things like facet wrap to divvy up the plot by categorical variables. So we're going to share with you a tutorial to help work through these kinds of examples and see how we created this input data in the first place. But this is like the general outline of it. And definitely ggplot is something that, you know, scientists use every day. It's something that you will notice once you know what the kind of default colors are and the default background colors and things like that. You'll notice like these plots popping up everywhere. But it's also, I think, fairly human readable, the code for it, you know. I mean, it takes a little bit of time to get used to ideas like AES, indicating the aesthetics, right? Like the color choices, the what's going on the X and the Y axis, the term mapping, right? Where we defined what was on the X axis and what was on the Y axis. Data, where we just told it to like generate a plot, like a blank plot, and use this data for any of the subsequent arguments. And then these geom functions that we chose, like geom box plot and jitter and geom point, will become more intuitive as you use them more. Does anyone have any questions about ggplot or anything that we covered today? Or Mike, did you have anything that you wanted us to like touch on?
No, I think it's fine. At first I was a bit worried if we'll get to the end, but you have really done this really well. And you got to the end of the last lesson. So maybe we can pick 2 questions and then give 5 minutes to do the post survey and then conclude the meeting.
Yeah.
That's
And
fine.
like I said, there's more detail, that we are going to provide you with, so you can go back through and learn, like even more examples of how to make plots with ggplot. But yeah, this is just a very quick, introduction to the basic concepts and the way that you build the plots up. How do you export the
Oh,
plot? That's a
yeah.
great question. Yeah. Okay, so we could say like GG save. So we've just been creating these plots and they've been plotting to the screen. But let's say I wanted to save this one. So I would say, what is this? We're looking at species and weight. So I could say like weight plot and then use that assignment operator. You don't have to do this part, but it's going to bother me that now that this is all shifted over. So I'm just going to have it redo the tabs. Maybe that part will stay the same. Okay, so I'll do this and execute it. And then I can use GG save. So I could say like GG save. And then the name of the file, like I could say weight plot dot png. And then the plot that I want to put there. So in this case, it could be weight plot. And then I could pass some extra information like the width that I want it to have, like maybe I want it to be 15 and have a height equal to 10. Oh. Okay. So now if I look in my directory, so if I go to home, data carpentry, now I have a PNG plot there that I could like share with my, boss, with my coworkers, with my teacher, with my students. Or if I'm submitting a paper, and I need to make PNG plots of it.
Jennifer,
Mhm.
another way, a lazy way of doing it as well.
Yeah.
On the far bottom right. Maybe
In ggplot. Yeah.
yeah.
There we
So
go.
you
So there's
could,
a
yeah,
save.
you can either like export. There's a button there as a PDF or an image, or
Yeah.
if the image at times you find that at this section it's a bit small, you can zoom it and then save it as a PNG.
Yeah.
Zoom
Okay.
and then you can
So
save.
that's definitely one way to do it. And it depends on how you're working, right? If you're
Yeah.
working on like a cluster, you may write something that runs as a script here, as an R script, rather than runs as like in an interactive session, so.
Yeah.
Great. Okay. Adding a
How about the
title.
title?
Yeah.
Yeah.
So we could put labels on here. So that would be something like, okay.
In the graph.
So I'll say labs. And maybe I'll say title equals my plot. And I just want to print this so we can see it. So. There we go. So there's my title. I can also rename the axes, right? So the species ID thing is like not looking great. It's like lowercase and it's got an underscore, which is, you know, you need that underscore to be able to use it as a column name, a variable name very easily. So that part's fine, but we might want to rename it when we get to the plotting. So I might say like, hey, I want to rename the X. X is going to be equal to species space ID. You know, I could change the capitalization and stuff, but that part is, you know, when what you write here is up to you. I could do the same thing with Y. Oh, I see. So you couldn't run facet wrap, but you got this. And so when you're saying facet wrap, what command were you trying to run for facet wrap? This one? Were you saying facet wrap vars genus?
Yes, facet wrap vars genus.
Okay. Okay. And are you sure you put vars around genus?
Yes, I did.
And you've got weight on the x-axis and y-axis is hindfoot.
I think the object GG proto.
Yeah, I'm not familiar with this error. Are you familiar, Mike?
So I'm thinking, so when you started writing ggplot, did you write ggplot or ggproto? You can see the...
No, I think because it knows facet wrap and the different functions within that.
But why is it saying ggproto object?
It may be like an object within ggplot. Like,
Okay.
can I see the full output? Is that everything? Or does it give you any other feedback? Let me try.
Actually, this is the what I've just said is the whole feedback, but not coming as an error, like a continuation of the,
Or like
like
a
the
warning
code
or
is trying to
something.
run, but it's not completely run to give me give me the plot, to give me the, yeah.
I don't know. That one has me a little stumped, but you've been able to plot before. It's just when you got to the facet wrap that it didn't.
Yes.
Can I copy this into, can you just try to copy this command exactly and see what you get?
Yeah.
I'm just going to put it really quick up online. So I'm putting it down at the bottom of the Etherpad.
It's already in the HackMD.
In HackMD at the very, very bottom. I'm adding it right now. Okay. So if you try to copy exactly that, do you still get an error? And in the meantime, while you're working on that, I just want to mention a couple further learning tools. So I really, really like Rosalind. When I was first learning to code, I found this very useful. So Rosalind will tell you that it's for learning to code in Python. But it's really just giving you simple coding exercises, and it'll give you a test, you know, like a code challenge basically. And then you write a little script to come up with an answer for the code challenge and submit it. And then it'll tell you whether or not you got it correct or incorrect. And then it'll give you like new input so you can test your script on different versions of input. So I think this is a really, really great tool when you're learning to program, to have something that'll basically be like a teacher for you, you know, like a tutor for you that'll check your work. And they start out with very simple, basic programming tasks in what's called the Python village. So, and you don't, like I said, you know, they'll be talking to you about Python as a coding language, but you can just jump straight to the lessons, like variables and arithmetic and strings and lists and conditions and loops, and write your own R code if you want to work in R for those same exercises. They aren't checking your code itself. They're just checking that you get the right answer. So it's very nice to have like a tutor that can check your work for you. And
Jennifer, maybe you can paste the link.
Yeah, I'm putting the link in notes and links on the,
Okay.
and I put this link specifically to the Python village. That's often where you want to start because that's like the simplest exercises. And then you can go on to like, they have silly names like the bioinformatics armory or things like that. But like it's really good. Whenever I learn a new language, oftentimes I go to Rosalind and work through their exercises in the language that I'm learning to help like get familiar with it.
Kevin got it now.
And there's also something called R Markdown that you can use to kind of like, if say, for example, you're sharing your work with a collaborator or your boss or something like that, where you can have your code kind of side by side with the plots that you create. So I think using R Markdown in RStudio is something to look into. And the organizers of this workshop are going to share with you tutorials from the workshop that you can work through that'll do what we did in the workshop, but going through it in more detail and touching on more, you know, like more ways to plot, for example, or more things that you can do with dplyr. Does anyone else have any suggestions that they find useful for beginning programming? I think there are actually suggestions for like Hadley Wickham's book in the documentation that you're going to get. So Hadley Wickham is, you know, kind of behind the design of ggplot. And he's a great, you know, like great at data visualization and data science. So he's got some books that are kind of like foundational. So I don't know, is it R for data science that you recommend in the documentation? That's a good one. I'll put the link. Oftentimes programming books like that, you know, especially written by someone who's very big in the field, can be very useful. Okay, so I don't know, Mike, if you want to take over to have everyone fill out the exit survey.
Yeah,
but
so I don't know if we do it now or we can share the email because now I see time is already
passed. Yeah.
gone. Yeah,
Well,
passed.
I just want to say thank you so much to the participants. Everybody was great at like asking questions, and you know, when you had an error message or something like that, you were great at sharing what the message was, which is very helpful to the group. Yeah, it faceted things. And to Kevin, so just because of time, I just pasted the exact answer. And now you can maybe go back through and compare what you wrote to what I wrote and look for where there's a difference, you know? So it could be a difference in like, you know, was there a space after a plus, or, you know, was some function spelled slightly differently? But so you can figure out like where that error came from by comparing the one that works from the one that doesn't, which is something you do all the time also in programming. So yeah, thank you so much, guys. You guys were great. And I don't know if Mike, if you have any closing comments for the workshop.
Yeah, sure. Thanks very much, Jennifer, for making it possible. Yeah, so I'll do an email this afternoon where I will share the Zoom link to the recordings and all the notes for all the sessions. So you'll notice that some sections have been skipped, but it's for you to now start learning and getting to, understand every bit. Again, I will also share a post survey link, and kindly, it doesn't take more than 5 minutes. Please take the time to do the post survey. I hope everyone has done the pre-survey. This actually helps us to now understand and have some data so that the next time we're doing such kind of workshop, we already getting feedbacks from you guys. And lastly, there's going to be a Twitter link where we're going to upload, so you can share your experience on the Twitter if you're in Twitter. Yeah, so that everyone can see that this was actually going on so well. So those are my remarks. So probably maybe I can ask Karega and David if they have any final thing to share, and then we can conclude this meeting. But otherwise, thanks very much for being a very interactive participant.
I can also echo what Micah said. First of all, is to appreciate Jennifer and Bernice in absentia for such a great opportunity to teach us and to bring us at par in terms of R programming. And thank you also so much for the participants, for your patience, and also you have been there throughout the sessions. Thank you also for being interactive. Thank you for the questions. Thank you also for answering questions as well. I can only imagine if you are not answering questions or you are not responding, but we so much appreciate. Something else to add on that is there are some people who have not registered on the HackMD. Please write your names, write your email address, so that also when some of these supplementary materials are being shared, that you won't miss out. And also the importance of us commenting in your Twitter, using your Twitter accounts, some of the experiences, is so that other people can know that such things occur, and so that you can also be ambassadors of BHKI for the upcoming meetings and workshops and trainings. Once again, I also have to thanks to my fellow helpers. Everybody was ready to help up to the task for any responsibility that has been rendered. There were a lot of behind the scene activities that were happening, and the helpers were there to make it successful. So thank you so much for everything, and see you then. And again, this is just the beginning. Continue, make good in your endeavors in learning programming, especially using R as a language. Thank you so much.
Can I add just one quick thing? Super quick.
Sure.
I just wanted to say that oftentimes people who have just learned a programming language, like, so once you've had a year and a half or so of experience, you may be the best suited to be like a helper at a workshop like this, because you still remember what parts were confusing to you. And oftentimes after a couple years of programming, people can do instructor training and then try to give lectures at workshops like this. So you can reach back to this organization to find out about instructor training, or whether you could be a helper once you get more used to it, because you'll have that valuable experience of remembering what parts were confusing to you.
Yeah, thanks, Jennifer. So before we leave, we need to take a photo. I think, Karega.
Yes, if everyone could just open up their cameras, that would be amazing. And remember to smile. We'll need a few more faces.
Okay, guys are driving to lunch.
A few more.
I think we can also now mention names here. Cynthia, Rispa, George. Yeah, you know, Kenyans will be Kenyans.
Irene, Cedric.
Rebecca,
mine is not able to do this, unfortunately.
okay.
But,
but
all right, big smiles. Big smiles, big smiles. And awesome. It's done. Should have done click so that you guys know that I've taken it. Thank you all for attending. Wish you all a very nice lunch. And if you can reach us via Twitter, you can reach us via email, and you can also be a part of our GitHub community. It's a very good place to continue learning how to code and to continue getting information. We'll keep on posting. Look out for emails, look out for more tweets, and we hope to see you next time. Thank you very much.
Thank you.
Thank you. Bye.
Thank you.